Y'all need to call me shit, all right? You guys come in here with your stupid little wrenches, thinking you can just start telling me what to do. Hey, streamer, why aren't you live, streamer? Huh? What's up, guys? How's it going? Hello, Melky. Host Hunter, Big Lacana, hey. Ipsav, what's up? This is a live streaming website. Interesting how Twitch staff's telling me how this website works. You're funny. What's up, Aiden? How you doing, buddy? Welcome, everybody. How are you? Pawn base, thanks, man. Appreciate that. It's been a minute. It has. I know. It's been a solid minute. I don't know how it works, man. Somehow my stuff hasn't been taken down prod yet. Yeah, I figured as much, Aiden. How's it going, buddy? Also, I hope the Fossabot updates have been good. I've been seeing your tweets about it and stuff, my man. I'm good, Host Hunter. How are you? Melky, how are you, my dude? How's everything in your side of the world? So, okay, there's a lot to talk about. It managed to migrate, only took 8 hours. I thought it'd take 3. That's normally how migrations go. Yeah, that's normally how they go. Okay, cool. So there's quite a bit of changes that have actually happened here. Let's talk about them. The first thing I want to talk about is here. Let me do this. Let me create a personal note for myself here. We're gonna create a new. How do I do this? Page. Yeah. Okay. So what's today's date? 0 to. What is today? What day are we on? I don't even know. It's 7? Okay. 07/2022. All right, so let's talk about the agenda for today. Because there's a lot to talk about. There's a lot that's actually been going on behind the scenes that you guys are not aware of. I know we've been not streaming as much lately. That's been purposeful. It's been for a lot of reasons, but we'll get into those in a second. So the first thing I want to talk about is the new streaming computer. So if you guys remember, we were crashing a lot before we left. And the main reason was because we had a older we'll call it a Frankenstein computer. Frankenstein computer that we use to stream on. And we did this for literally we did this for up to 3 years. So we either streamed on an older Frankenstein computer or we streamed on a laptop. But the main thing we want to talk about is we were crashing a lot before we left, and this old computer was kind of a computer that was like bits and pieces of like a bunch of different parts and things that we could basically get our hands on. The biggest value, right? So we're going to say the biggest value we got from this PC was a dedicated GPU. Now, at the time, it's like a 970 super something. I don't know, whatever. But it's basically got like, I think, like 8 gigabytes of RAM, whatever. And so the nice thing about this was we were really able to lean on this GPU. The biggest weakness from this PC was a very old CPU. This was actually an i3 that was like, I think would go up to like 3.2 gigahertz max, maybe, or something like that. And so we had, because of this, we had bad bottlenecks, CPU bottlenecks, which would cause OBS to crash on, let's say, we'll call these on transitions or moments of high rendering. And so the idea here is like, if I had to do something like this, or do something like this, those re-renders were affecting the CPU to the point where those scenes and those sources switching in and out would bug out the CPU. It'd flick to 100 for a second, and OBS would trip and die. And so that was the scenario. We were basically essentially we were at our limits with CPU and not GPU. So we found ourselves in a scenario where we needed a new streaming computer because of really a lot of these reasons. And the hard challenge was we didn't want to stream until we had this solved. And so, yeah, we didn't. We were like, all right, well, it's really not useful to stream on computers that don't work. And on top of that, we don't want to deal with, okay, stream crashed, stuff like that. Like, stream crashes suck. They're not fun at all to deal with. And so we decided to build a brand new computer. And we wanted to, for one, save as much money as we could, while simultaneously getting the biggest bang for our buck that we could as well. I'm not going to go into like the massive details of the computer itself, but I am going to talk about basically how we set it up and why we set it up the way that we did. But you might notice if you look very carefully, for example, like the desktop quality might be a little bit better, might be a little noticeably better via the stream. The frame rate and the latency might have smoothed out a little bit more, and things like that. We're not as glitchy in certain scenarios, or even the audio might not be as peaky or as glitchy as it was before. We basically spent a whole 2 weeks just re-rigging and setting up everything so that all of these problems could be solved. And we didn't want to stream until we had this solved. Now, with the new streaming computer, we could talk a little bit about the goals of it. And so, for example, if we say like new streaming computer, right? The biggest goal for it was we wanted to make it so that nothing used NDI. We liked NDI. NDI is a really, really neat tool. But NDI is not something that you can easily scale. It really isn't. We have, like, listen, dude, I would love to talk to the engineers at NDI, whoever make it, because I could have a very intimate conversation with them about that piece of software. I know its limitations very well. We've pushed it to its limits. NDI seems to be a very, very great hardware solution in the sense of if you're going out and you're buying a camera that's meant to be on a network that you can easily just grab and you don't have to like drop hundreds of wires through walls, through conduits, through all these other things to your patch panels. That's what NDI solves, in my opinion. That's what it really solves. Then you create a very high bandwidth wireless network, and then you send all of your data signal through that, right? It's a good solution, and it's not one that's even terrible in the sense that you could even just go with one cable and use Ethernet for everything, right? And just plug everything in Ethernet, which is also a good solution. The challenge is when you start using it on a computer, it's massively limited with what it can do. And so what we'll say is on hardware, works out of the box, and these are things like built into cameras, devices, etc. Right? On software, works not as well, and this is like desktops, laptops, etc. There's not really a lot of support for NDI when it comes to software. OBS has a very, very basic wrapper that handles the actual initiation of connections and things like that, but everything under the hood is just the NDI binary. If you really want a really good interaction with NDI in the sense of just even using it as sources, you really have to program your own solution to do that. OBS is nice. It goes pretty far, but it's not perfect. And the problem with OBS as well is OBS does not like CPU bursts, as we have discovered, and NDI really only relies on CPU. If you guys don't know how NDI works, it basically sends out the completely uncompressed footage or rendered frames over the network at very high speeds. We're talking 100 megabits per second for 10 80p feed. So yeah, webcam able, no problem, dude. I think we have, yeah, there you go. But basically the idea is that NDI can take, for example, my desktop feed, send that out over the network completely uncompressed at 100 megabits per second or more, which it does. It actually goes up to like 150, something like that. And then you can grab that over the network at that same bit rate. So you're sending out a network interface at like 150 megabits per second, and then you're using another network interface to pull it down on another computer at 150 megabits per second. So it becomes a link, you know, almost like a digital cable. And then I can use that source in, you know, my OBS or whatever. And that's how we've done a lot of our, you know, that's how we've done a lot of our stuff here at the ALT-F4 stream. The thing about that, though, is when you start talking about using multiple sources, and on top of it, not just multiple sources, but also talking about using graphical sources. So camera sources aren't so bad because of low bit rates. At the end of the day, a camera just can't do the same bit rate that something like a graphical sources are worse due to high, if not unlimited bit rates. This is where it becomes very challenging, and this is why NDI we wanted to step away from. For a very long time, we've wanted to be able to provide you guys with a party mode setup that we've talked about using before in the past, of being able to switch between like me and Atoda's scenes very easily and effortlessly. And we needed access to having, you know, all of these things as different sources. Atoda's desktop needs to be a source. My camera needs to be a source. My desktop needs to be a source, right? All of these things needs to be individual sources. Well, 2 desktops running Valorant, for example, over NDI send about 250 plus megabits per second per source. So that's my desktop and Atoda's desktop. Those are just those 2 sources. So when we talk about cameras, two cameras running, you know, 1080p over NDI send out about 100 megabits per second per source. So as I said, oh, thank you. Mbps, yeah, there you go, megabits per second, whatever. As I said, when it's very simple or something that is like not as high bit rate, it's not as difficult to use NDI. But when you start using NDI with, you know, very highly graphical interfaces, or, you know, just games in general, you can flood your network with traffic, and we have. We've shipped terabyte, literally up to, or not terabyte, gigabyte, up to a gigabit per second traffic over a network interface, basically flooded the whole interface with NDI sources. So NDI just became something that wasn't very scalable, right? It's something we could use every now and then, but it wasn't something we could use all the time. And on top of it, NDI requires mostly CPU for network transfer and encoding into OBS scene. So that's the other thing to note. NDI doesn't let you lean on the graphics card for encoding for any reason. So those, even though those were coming in over CPU, or over the network and uncompressed, there's still work that had to be done there, right? Like, yes, we're sending out an uncompressed feed over NDI, and yes, we have, the ability of downloading it at that up to, gigabit, but it still has to be processed, you know what I mean? And so when you start saying like, okay, you've got, 250 megabits per second of data that needs to be processed, while you got another one, and then you got 200, like it's like, whoa, dog. Okay, hold on. Now, does that mean that you couldn't throw money at the problem? Sure, you could buy a super banger computer and, probably continue using NDI. But you're still going to have another issue, which is controlling the NDI sources. OBS has, again, some decent integrations with like OBS NDI, which is a really cool plugin we've used for years now. But it doesn't really unlock the complete potential of OBS, of NDI, and like all the options that you can have with it. And so it's really just like all or nothing with the plugin. You either flood everything or you go nothing. But NDI does have controls over like qualities and things like that you can sense, so you can kind of throttle it a bit, but there's really no access to that whatsoever over the OBS interface. And so you'd have to program that as well. So when we talk about like problem solving as a streamer, the real goal here was we wanted a new streaming computer or a new streaming configuration with a new computer that complements our stream setup and content creation, right? So one of the things that we have, right, hands down with our content creation is multiple sources. We've kind of discovered that NDI just doesn't do that great with multiple sources. And so, yeah, NDI was something that we did not want to use. Another thing that we wanted to do was we wanted to say audio is all, what's it called? Wired. And this can mean anything from analog to digital. Or this can mean from, I think that's really it. Analog to, or analog to analog. But the idea here is that analog to digital would really just be USB connection to host, right? Whereas analog to analog would be like microphones, other sources, right? This was another thing, and we really wanted this for lowest latency possible and highest quality possible. So before, when we were doing audio also got shipped out. Audio is also shipped with video, so no additional source required. So that's one thing that was kind of I guess it was nice about NDI was NDI did include the audio for us, but the downside is if any of these things broke, then the audio broke as well. We could have I don't know if you guys remember, but when we were streaming, every now and then, it's called Notion. Every now and then, we would people would be like, "Oh, you're lagging, like you're lagging," and so I'd be like, "Oh, hang on a second," and so then I would go in and change something or reset the OBS scene, and then NDI would have caught itself back up. NDI has a natural like delay as well. It can slowly start dropping packets over a period of time. Anybody who works at Twitch and has dealt with the streaming part of it, you are definitely aware of this, that as you drop frames over a period of time, you also get slowly delayed. And it's a hard thing to realize because it's an ongoing process that happens depending on how much frames you drop. So for example, if you're dropping, a few frames every second, and it's so not, or it's barely noticeable that you can't really tell, and then you start going like, why is my desktop so delayed from my laptop or whatever? That's why, because you've probably been dropping frames over, a certain network or whatever, and you got to refresh to catch back up. And that was the same thing that was happening with NDI. Or we were dropping frames, and so because of that, we would slowly start getting delayed in our feed to the streaming computer. Another thing was, again, we wanted all audio to be wired, and the reason for that is because we hated dealing with virtual cables. So we're going to say hated dealing with virtual cables. If you have ever used anything like voice meter, not bad. We love it. However, virtual cables suck. It's just in general, you know what I mean? We love voice meter, but like virtual cables in general suck. And they're just really annoying to deal with. It became to where we had up to, I think, like 6 virtual cables per computer. And that would be like for my computer, for Tota's computer, for the streaming computer. And it just became this ridiculous thing where it's like, if we can't change it, then we really can't do anything about it. And if we do change it, then everything is broken. And so virtual cables were just really, really annoying to deal with. And on top of that, virtual cables introduced unwanted latency. And that was another thing that we wanted, which is we wanted the lowest latency possible. So having virtual cables that also introduce latency was just, it was annoying. So we wanted lowest latency possible, highest quality possible. We wanted to say analog to analog. So like my microphone, this microphone here is a normal XLR microphone. I don't have the USB version of this microphone. It goes directly in. And the same thing for all of our other sources. So our video game, any other thing like that, all of those would go into hardwire, and then those get sent out via something. And so that's the analog to digital part, is the something. We have all of our sources plugged into our Go XLRs, which we've had these for a while. The Go XLRs are not old. But what we do is we each send a line out, which I'll show you guys in a minute. We send a line out to the streaming computer that will also have its own device on it that I'll show you guys in a minute. That essentially groups those two sources together and then makes them available inside of OBS, so that what you hear right now is an actual analog device plugged into the streaming computer receiving analog signals from our each of our Go XLRs. But I'll make that more sense, or I'll make that make more sense in a second. And then the third final thing I would say is we wanted something that would last a while. We want to play video games on stream, right? Video games increasingly get harder to play as they get better with graphics, right? Increasingly harder to play as they get better with graphics. To stream the best graphics possible, we need to take an analog approach and build a system that lasts a while. And so that is actually going to go to the final thing here. And this is actually going to be before something would last a while, is we want to say video is all wired. So when we said that we're not going to use NDI for anything, and we know that we're going to do all of the audio wired, we had to make a decision on how we were going to ship the video. Again, we knew how we were getting our audio. If we solved the audio problem through our Go XLRs and all the routing, like if you can hear me, the next thing we need to solve is video. And so we looked at a lot of streamers who have done a lot of different solutions to this. You can do multiple computers, you can do one computer, you can do capture cards, you can do all these other types of things. The biggest goal for us was to make it so that if I upgraded my computer or Toda upgraded his computer, we wouldn't have to have such a detrimental hit on the streaming computer. And so the idea was, in the same way that we were cutting out latency and keeping highest quality possible wiring our audio, we would do the same thing with our video. And so with video all being wired, the benefits here would be, hardware solution for rendering sources imported into OBS. Takes load off of GPU on streaming computer per source, right? And so this was one of the biggest wins of saying we're going to do everything wired via video. Is we've now removed all of the overhead that NDI gave us, any of the networking throughput, any of the CPU throughput. At this point, these are all just video sources that OBS is now bringing in and using. So us doing video is wired allowed us to, say, okay, well, we don't have to build a system that needs a 2080 Ti or a 3080 or a 3060 or whatever. We can still have a decent, graphics card and scale for a while. And as I said before, we knew that we didn't have, our biggest value was the GPU, right? This Frankenstein computer had a bad CPU, but it didn't have a bad GPU. So we knew we could keep that GPU for a while if we wanted. So yeah, with video going wired as well, again, that would mean that OBS wouldn't have to render any of those sources. We'd have hardware for those sources, and it would remove all of the GPU as well. So any kind of hardware acceleration we got out of it or anything like that, that would all go onto those as well. The challenge here, though, is BG uses a 144 hertz monitor, which HDMI does not support. I'm just going to TLDR this and say HDMI 2.0 can go up to 120 hertz, which BG was fine with using. So that's the one caveat to this video is wired solution is I use a 144 hertz monitor. I have a very nice Asus monitor that I've had for quite some time now since I built my computer. And I like to play, first person shooters and other things like that. And so I wanted to be able to keep at least, like if this monitor went to 60 hertz, I was going to be really disappointed. I really was. And it was one of the things I told the Toad. I was like, dude, if I have to drop my monitor down to 60 hertz, I'm going to be really sad. So I wasn't able to get to 144, unfortunately. That would require me to do pure DisplayPort, which is a lot more money. It is possible, but it's like thousands of dollars to use a DisplayPort switch, or just go HDMI 2 and go 120 hertz. So what's interesting is the signal that you guys are seeing right now on the stream, that you guys are seeing me, move around with right here. This is going technically through the computer in OBS and then to my monitor, which I'll show you guys here in a second. So that was the main reason why we wanted to build a streaming computer. We didn't want to use NDI anymore. We wanted all of our audio to be wired. We wanted all of our video to be wired, and we wanted something that would last a while. So with all these considerations, we ended up building a pretty decent system. We built one close to our similar spec that we've used. We kept with Intel. We've got I actually don't remember the specs. We'll get the specs though. Don't worry. I'll share that all with you guys too. And I'll show you guys how I'm going to share it with you guys. So I hope you're excited about that. but yeah, we took a vacation a week and a half ago, so 2 weeks ago now, basically. And during that break, all of our parts got shipped. They got delivered to the house, and so once we got back, we were ready to build our new system. So all last week we spent all of it just accomplishing these goals, setting up the new system, getting rid of all of the NDI, wiring all of the audio, getting all of that set up, getting our video all wired and set up, troubleshooting the setup, making sure that everything sounded okay. Double checking, triple checking. So what's fun is that today, chat, this is the first stream with the new setup. And what's pretty cool is you might ask yourself, well, how did you guys solve like controlling it remotely? Well, this right here is my iPad. And one of the cool things about us doing this way now is that we can use Stream Deck to remotely control the streaming computer. So that was one of the interesting challenges that we had to tackle, was like, how would I be able to control it? Like if I wanted to say, okay, I want to hide the desktop really quickly. Right? How would I do that? I'm not touching the streaming computer at all, but I am using the wireless Stream Deck app to be able to do that. So yeah, we're testing it out today. We'll see how it goes. I am going to show you guys just one other thing before I get into the other part of the agenda, which is the new community project. And that's going to be going, what is it? Hold on. Yeah, let's go to Lucid really quickly. So I want to show you guys how we have all of this wired up so that you can get a good understanding of me saying like, okay, cool, we don't want to use NDI, we want to have wired audio, wired video, and something that lasts a while. Well, what would that look like? I'm gonna show you guys what that would look like right now. You guys know how I love my charts. So we're gonna go page settings, make this a little bit darker. There we go, perfect. Okay, so what we want to do is we first want to talk about our sources, right? So our main source here is going to be, which is funny, this is all still DevOps related stuff. This is DevOps stuff for our company. Okay, so let's talk about our sources first. We're going to talk about our computers, right? Let's talk about the computers first, because those are really the most troublesome. The computers have got all of the load of the GPU. And so here, let's do this. Let's say there's a reason why I'm doing this for you guys. Don't worry. You're gonna thank me later. You can go, oh my gosh, BG, thank you so much. Hold on. How did this get over here? I wonder. That's 2, right? That is 2. I love Notion. I really do. Shout out to Notion if you guys want to, like, sponsor us or whatever. I appreciate it. How did this definitely got over here though, eh? Yeah, look at that. New streaming computer. Oh, it like okay, let's get rid of this. There it is. Okay, that was odd. New community project. Okay, so we're talking about new streaming computer. Let's talk about the new wiring setup. Streaming wiring setup. And when we talk about that, we're going to want to talk about sources first and foremost. And those sources are going to be desktops, right? Oh, dang it. What? Oh, you don't do 4? That sucks. They're going to be desktops, and they're going to be cameras, right? Now, there's one commonality between all of these. Is this 3? 1, 2, 3. 1, 2, 3. It is 3 sources. And that's going to be... Oh, that sucks that I can't do 4. All right, let's do this. All sources have one thing, or all, we'll say all video sources. All video sources have one common trait, which is they all use HDMI. Because of this, we can rely on things like HDMI capture cards, right? And switches for routing video, which is what we do. In this case, we purchased for desktop sources 2 capture cards, and that's because we have 2 computers. And so let me go ahead and go back here and bring in our computers. Ooh, let's use this one. I like that one. That one's fun. We'll say that this one is a Tota. This one is a Tota's computer, right? This one is BG, or my computer. And then what we're going to do is we're going to add one more computer here. And we're going to call this one the stream computer, right? Now, if we talk about my computer and Atota's computer here for just a second, right? We know that these computers have, hell yeah, supercomputers. I mean, at this point, they pretty much are. We have monitors plugged into them, right? LCD, duh. So here, let's do this. We'll say LCD here and LCD here. Now, the reason why I'm putting these monitors into the workflow is kind of important. The reason for them is because they're actually a part of the wiring setup. And the reason for that is because this stream computer also has a capture card in it. As a matter of fact, it has 2 capture cards in it. It's not exactly what I was looking for. Oh, that kind of works. Smart card. Yeah, that works. We'll do that. We'll use smart card, whatever this thing is. And we'll make this like purple, right? Twitch purple, something like that. There we go. And we'll call this our capture card A. And this one is going to be our capture card B. Let's make this text. How doth I use a new color? Why do you not have the color white in here, Lucid Charts? You're letting me down. You know that? Done. There we go. Does it stay there now? Why don't you like the color white? Oh, I did the wrong thing. Dang it. Is it in there? Oh, it's still not. What? Add my color. There we go. Okay. So what happens is the stream computer has 2 capture cards plugged into it. Capture card A and capture card B. Now remember, like I told you guys before, the goal here is to not use anything but raw video sources. Sounds dirty. There we go. So once we've got the stream computer with 2 capture cards, we can now plug the computers into them. The way that this works is kind of interesting, where we actually, let's move this down here since the capture cards I think make more sense to come down here. Where we, yeah, it's actually very fun. Where we basically say, okay, well, the first source in the capture card, or basically the source in the capture card, needs to be the computer. Like that. So we say, okay, well, let's go ahead and do that then. We're going to take both computers and we're going to plug them into the capture cards. So at this point, whenever I do anything on my computer, then this capture card is going to register, you know, get that signal and send it off to the video source in OBS. Same thing for this capture card. But there's one thing missing in this connection, which is what, chat? What do you think is missing? It's pretty self-explanatory. The monitors aren't plugged in. So we can't see anything, right? So you might ask yourselves, well, okay, how does that work, right? Well, it works exactly like this. We have to plug our monitors into the capture cards because our source and our signal goes into the capture cards. So the way our studio is set up, chat, is our main sources for our supercomputers go into our capture cards that are plugged into our stream computer. And then these capture cards send an output feed for our monitors to be able to use and see. So we have 2 per computer, very long HDMI cables that route through the office to each one of these capture cards and back to each monitor. Does anyone have any questions about how we solved our video problem? HDMI splitters. Good question. Okay, so that is actually something else that we included. I didn't put it on the chart, but yes, there is actually HDMI splitters here as well now. Per source. So if we say like switch, doesn't really, yeah, we'll just use like this. So these are actually HDMI switches that we have per desk, I guess you could say. Like I've got one on my desk, he's got one on his desk. And when this is going to be an HDMI switch. And this allows us to use multiple sources to where a Tota can, say for example, not just have this, but then have like gaming. Is there like a controller? That's funny. There we go. Yeah, like a controller. So, oops, something like this. Yeah. And so then what happens is, you know, here we go. The switch is plugged in, and so is his computer. Boop. Like so. Yeah. We'll say Nintendo Switch. We are in the same room. Yeah. He's right behind me, actually. That's his whole setup behind me. Which is funny because I could technically use his camera right now if I wanted to, because they're all plugged into the same system. That's going to be the next thing I'm going to explain in a second. Wait, what? What did you do? Okay. I want the color. Oh, okay, cool. Nintendo Switch, yeah. Do like this. Cool. Okay, so like I said, all of these are HDMI 2.0 switch or HDMI 2.0 signal cables, and this HDMI switch can also go up to, I think, 120 hertz, 1080p HDMI switch. Yeah. So anything in this switch can go up to 120 hertz and be able to send that to capture card A and send that out to LCD monitor. So the other thing to note, chat, is if a Tota wants to play video games on stream, then all he has to do is change his switch source here, and it'll change the monitor output as well. Because remember, the sources go into the HDMI switch, and then they go directly into the capture card, right? So what he's seeing really is not his computer, but what he's now seeing is whatever is going through that HDMI switch. And I'm literally the exact same thing. I have an HDMI switch as well. All we have to do is just like flip these or keep them the same, really. But I have an HDMI switch over here as well, and this allows me to, you know, route in anything I want to. I have my own Nintendo Switch too. I can, you know, switch over to my Switch, and then it'll show up on my monitor just like his would. And again, all of this is at 120 hertz. Does anyone have any questions about the video part and how we solved it? Now, if you were to ask me, hey, BG, in your personal experience, what's the best streaming setup? Right? Like what's going to give you the most power, right? The most quality. I want to have that like best quality scenario. It's going to be this, in my personal opinion. Yeah. We've explored a lot of different options. We really have. Again, we've done things like NDI. We've done things like just not even NDI, but RTMP. You guys know what RTMP is, which is what you send to Twitch, actually. I think hands down, this is why every big streamer eventually ends up going with pure hardware as a solution. Because when you go this route, you get, again, all of the performance distributed where you want it to be, where you're using like capture cards to handle those sources for you. You don't have to worry about like, oh, well, how big of a GPU do I need? It doesn't matter. It's handled per source. Audio is, well, I'll show you guys audio in a second as well. But audio is very similar to that too. Yeah, I genuinely think and I think that if you're going to go a capture card route, don't do the little like USB HDMI one that Elgato, like just get their PCI one. They've got a PCI one that you can actually plug into your computer. Get that one. Like get the capture cards that you actually plug into your computer. And you can get one that plugs in via USB. Like for example, we have an AverMedia capture card, which is the one that I use. And the reason why I use that one is because it supports the 120 hertz signal. But it does use a USB 3.1 connection. So it's using like a super fast thing. And I'm going to include all of this in the documentation as well. Yeah, video capture. Live gamer. Yeah, it's this one. 4K. No? This one? Ultra? Yeah, this one. I've got this one. This one right here. Yeah, 4K P60. So yeah, so if I wanted to, I could go up to 4K pass through. Now the goal here is the pass through, right? That's what you want. Is you want this pass through approach. So we're gonna say pass through. That's really the goal, is to get your signal to be a pass through signal. If you are trying to handle your encoding for your signals any other way, I just say to you, Godspeed. But I really think pass-through is going to be what you want long-term. I think pass-through is just, again, it's the most scalable from what we've seen, even just with the two sources. Technically, we don't really have two sources. We've got like, 1, 2, 3, 4 sources, right? But it's also very much on what we want to do. Like for a very long time, we weren't playing any video games because we couldn't support more than two sources. But now that we can, there you go. Now that we can, it's a lot different. Are you capturing at 120 hertz too? Yes, I am. Yeah, my monitor right now is at 120 hertz. The signal on my monitor is 120 hertz right now. So it's going completely through. Now it will, the frame rate, actually, hold on. If you're talking about just the frame rate, so the hertz is different than the frame rate, right? When it says like 1080p 60, right? Then that's just going to be 60 frames per second, no matter what hertz you send through that signal, right? If you have a 120 hertz capture card, then you can view at 120 hertz, but the frame rate is only whatever the frame rate can be. So, 60, whatever. I can send a signal, right, at 120 hertz, but it only captures at 60p 1080. And I think 60p 4K as well. Is that what this says? Yeah, so you can get a refresh rate of, oh, no, my bad. So you can actually get 240 hertz. Wait, really? I don't know if this is the one I have then. I don't know if mine does. Maybe it does do this. This compact device can pass through high refresh rates of 240 on a full HD signal. If your LGU is compatible. Oh, right. Yeah. So I think this means I need HDMI 2.0 or something like that. And I think my monitor doesn't have it. So if I got a newer monitor, I could get up to 240 hertz through this. Yeah. I think the monitor I have has got HDMI like 1.2 or something. Whatever's the step between 1 and 2 is what this has got. So yeah, you can actually get up to 240. But like I said, you'll only get 4K 60 frames through, the actual connector or the actual source itself. Okay, cool. So what happens when you watch DRM stuff? Yo, Foob, good question. That's a super good question. It doesn't work. Well, it depends. So on the AverMedia card, I tried streaming my MacBooks. That didn't work. Apparently, Apple is now doing what is called HDCP, which is high bandwidth digital content protection. If you send out an and this is I think this is just like with a recent release of the Mac OS. But if you try doing any type of HDMI signal capture, at least through the AverMedia, it will detect the HDCP and be like, no, sir. And it just doesn't let you view the signal. So that is a downside. This knows how to, I guess the downside is that it knows how to properly handle HDCP. You might be able to find something that doesn't. Like, I don't know if the Elgatos do. That would be an interesting question. We can test it because we're actually using both. This capture card for a Toda is an Elgato capture card. He's got the Elgato capture card. He's got the HD Pro, I think is what it is. The one before the 4K 60. I don't think it's this one. I think it's the one before this one. The HD Pro. Does that make sense? The Elgato HD Pro. And that is basically 1080p 60 hertz. And then mine is the AverMedia Ultra thing, and that goes up to 240 hertz. I think it's 4K. No, I don't know if it's 4K. 4K 60p 1080p 240 hertz, something like that. I don't know, something like that. Anyways, and again, this one is via a USB. If we want to be just a little bit more specific, just so that you guys have all the details here. This one is PCIe, right? So this is actually in the motherboard, connected to the motherboard, the Elgato. But this one is USB 3.1. So this is actually outside of the computer, plugged into a USB 3.1 port. We didn't go with an internal card for this because this AverMedia solution was just the best purchase for the best bang for the buck. And hands down, we always go for the best bang for the buck here. I'm never gonna suggest you guys something that's just like outrageously expensive or something like that. We're always gonna go for, I don't know why it's glitching like this, but we're always gonna go for like, what's going to save us money, but also get us the highest performance possible. And this, for us, a video solution, this was really it. Does it interpolate to upsample? Does it interpolate to upsample? That's a good question. I don't know. I want to say I know what you're asking because I know what upsample means, but I don't know what you mean by interpolate upsample. Maybe if you can rephrase your question, I could try and help answer it. Are you saying that it just does it upsample to like for example, if it's at 1080, does it upsample to 4K? No, I don't think it does that. I think it's a pass through. So it's just gonna pass through the signal that you give it, not upsample it. But yeah, So like I said before, chat, what's the cool thing about this? Well, check this out. Watch this. I'm going to do something really fast. So say I was like, you know what, chat, let's play some games. I can do that now. And I don't have to do anything different. As a matter of fact, I can literally go in here. Watch this. We're going to watch the 0 bitrate difference. This is what a capture card gives you, chat. Now, I'm not going to play the game. I'm just going to show you live what I mean by the performance difference. Look at this. We're now in a video game. We went from coding at a very, very low bit rate to a very high bit rate. It's not affecting your stream at all. The quality, the frame rate hasn't dropped. Right? These are all things that people like strive to have. So let's go to the firing range. Look at this. That glitch was actually on my end. that was the game itself glitching out. But look at this, chat. Oops. Tell me how it looks for you, would be my question. How it sounds. Look at this. Look at this. No frame rate drops. Pretty cool, huh? So this is what we wanted. This is what we wanted right here, is to be able to do that. Be able to be like, okay, now we're playing video games. Now, the bitrate drops that we do have, so the artifacts that you are going to see, that's just Twitch at the end of the day. So these artifacts are going to be basically the same artifacts that you would see on any other stream. The only difference here would be bitrate. So for example, like Shroud actually gets to stream at 8K. He gets to stream at 2K more bitrate than most people do because of just, you know, his agreement, I would suppose, or I would guess. But this is the best quality that you're going to get out of a 6K signal playing a high quality video game. Now I could drop the quality of my game a bit, right? Like I could, and it would help with the artifacting a bit, but I don't have motion blur or anything like that on, right? I'm basically just streaming out directly to you guys my signal. So tell me, what do you think? How does it look? Does it look good? All right, I'm gonna hop out of this in a second. Oops. All right, let's get out of here. So yeah, and so then I could be like, yeah, I can see your cam also fragments when you spin a bunch totally on Twitch side. Exactly. Yeah, that's gonna be the actual, you know, the actual stream itself rendering out. And so then there you go. Now we're back into, you know, we're back into our programming. So yeah, that was the goal. Now, again, when I talk to you guys about, like, think about how difficult it is for a lot of streamers to, say, go from one context of something to another, right? We, you know, like I said, we wanted to be able to program and then go to like video games and then maybe go to like just chatting or things like that. Another thing that I can show you guys really quickly. Well, Atoda's not here, so I guess I can't show it to you. But like we have also got completely other scenes now that allows us to just kind of chat with you guys more directly, or I chat with you guys more directly, and have more of a chill vibe, and allow for more different types of content too. It's not easy to do that. You know, a lot of streamers you'll see, oh, I gotta switch this and change this and do this, or oh, I gotta do this, and you know, whatever. For us, it's all, you know, it's all in one place. You see all of our, you know, all of our sources through HDMI pass through, and then you hear all of our audio through the, you know, the audio lines. So we can talk about the audio lines really quickly as well. The next thing we would really want to do, whoops, here we go, is we'd want, say, we'd probably want some more mixers, honestly. I wonder if they have like a mixer. Inline mixer. That we don't. Okay, so I'll just use this switch, and then we'll use this as well. So the next thing we want to talk about is the audio. So the audio in itself is super, super challenging. Anybody who's ever streamed on Twitch, I'm sure, or ever streamed before in general, can attest to this. Audio is very annoying. It's not very fun to deal with, at all. And so we've gone through a bunch of different audio setups as well. We've used USB microphones to avoid having to use mixers. We've eventually gotten mixers and used things like Voicemeeter to avoid having to like send that signal across multiple hosts. And now we've, as I told you guys before, fallen into this whole like, wired solution where everything across the board is wired. Yo, what up, Atoda? Thank you for the resub, my dude. Where everything is wired. And so because of that, what we really needed to do is we needed a way of sending out our analog audio signals continually analog, and then get those in an analog mixer, and then add them to this, or add that audio source to the stream as well, basically. And so what that looks like a bit more, if we kind of like just move this up here, let's go ahead and I'm gonna swing this guy around like this. Oops, let's just swing this guy like here. There we go. And then I should be able to actually flip the text too. Yeah, there we go. And why we're doing this is because this is actually going to be our new stream audio interface. Now, this audio interface is going to take each of our signals from our individual computers and plug that into the stream machine. Right? So this is the first place we're going to start, which is the actual stream machine. Just like we did before with the Avermedias, we're going to do the same thing with the audio interface. So this is USB as well, USB 3.1 as well. There we go. And then what we need is we need 2 more of these. And this will be the Atoda, or this will be Atoda audio interface. And then this will be BG audio interface. Right? Make sense? And so then what we do is we say, okay, Atoda's audio gets plugged into this interface via USB 3.1. There's a reason why I'm making all of this, chat. There's gonna be a big finish. I promise. I'm excited about it. And then again, it's gonna be the same thing here for me. USB 3.1. Yep. Okay. All right. So we now have our audio interface. And actually, I think what I'm going to do, just to make this a little bit easier on the diagram, is I'm going to put this here. I'm going to put this I think it's like right here, something like that. Yeah. And then we'll do this out of this. BG. USB 3.1. Yo, what's up? I promise this is a part of the reveal. How you doing? All right. There we go. Cool. Okay. So like I said, we've got a audio interface plugged into a Tota's computer and an audio interface plugged into my computer. Now, just like the switch here, where we're combining a bunch of audio or a bunch of video sources and then sending that source out via HDMI pass-through, we're doing the exact same thing here with the audio interfaces. Where, oh, is it? Sorry. Yeah, it's hard to tell sometimes. There you go. It's the same thing where the audio interfaces, where these audio interfaces will have like microphones plugged into them and other things like that. And then these send out a signal to the stream audio interface via, I think it's 1/4 inch or 1/8 inch or whatever. But this is line out is what this is right here. Oops. Line out. So each audio interface has a line out function on it, or a line out connection on it that we use to send those then out to the stream interface, stream audio interface. There we go. So yeah, like I said, what happens is my interface, my audio interface, and a Tota's audio interface have line outs that are 1/4 inch, or fourth inch, whatever. I don't know. And then those get connected into the stream audio interface. Now they actually have 1/4 to 1/8 inch, I think, basically the normal like phono or phono cables. Those get plugged into the stream audio interface, and then that signal gets sent out to the stream. So what does this all mean, essentially, chat? This is the complete setup here. What does this all mean? Well, it means, for starters, we have a lot more cables in our office than we had before, which is 100% true. We definitely do. But when we started thinking about how we wanted to solve these problems, we really had to focus on how we solved it best for us. Now, I've shown you guys tons of charts before, and I've always told you, like, whenever you see a chart that has really good like structuring or patterning or standardization, something like that, then it's normally going to look good as well. And I will say that I think this chart looks as good as it does because we spent a lot of time just thinking about how we wanted to set this up, how we wanted to replicate this, how, if it's in one spot over here, how can it be? Remember, these are two separate computers, chat. Two separate computers. This is my whole setup over here, and this is a Tota's whole setup over here, right? And the goal of our stream for the longest time has always been to be able to stream, you know, both of our content at the highest quality possible without affecting each other's streams or affecting each other's content creation, things like that. And where we could merge that content creation together when we wanted to. There was no easy way to do that with you know, having everything on one computer and then having everything on another computer. We really had to take it back and say, like, okay, how do we make this so that we just have a bunch of sources and now we can control those sources? Do you have a common streaming PC? Yeah, that's this computer right here. So we'll say a Tota PC or a Tota computer, right? And then this one is BG computer. And then this is the stream computer. Yeah, that's this right here. So this is a computer, this is a computer, and this is a computer. Yep, exactly. Yeah, exactly. And remember, the whole point of the capture cards, the audio interfaces, is to alleviate what the stream computer has to do. So for right now, if I go into the task manager and I look at the current resource usage on the stream computer, we're using 20%. Or at least for the past 10 minutes, we've been using only 20% of the CPU. And for the past 20 minutes, we've only been using 25% of the GPU. Yeah. It was really crucial to do it this way. Where's it stored? You live in separate locations. No, we live in the same house now. Yeah. His whole setup's right behind me, right here. Yeah. So we do have the benefit of being in the same office now, but we still had to set this up. And this is our studio setup basically. Now the reason why I showed you all of this is because I wanted to talk to you guys about the new community tool, or the new community project that I've been working on for a while now. I've been talking to you guys for almost like what, 2-3 years now. Like we've been doing this streaming thing for a minute. And during this time period, we have accumulated documentation like this, right? Really cool charts and things that allow you guys to kind of see how we set everything up and how we configure things. But what'll happen is we will do this, right? We'll have these streams, we'll have these talks, and it'll be fun. And then I really have to just say, like, all right, go check the VOD. You know, if you want this information, go check the VOD, you know. And that's just not super easily re-grokkable, right? You can't, like, later on, if, like, for example, any of you guys right now watching this were like, this is really cool. If any of you guys are sitting here going, this is really cool. However, I could never pick this up later because I have no idea what you're doing right now, and I can't pay attention to all of this wow. All of these different, like, you know, details and things like that. Well, that's okay, because I've been thinking about that for a long time, but I don't want you guys to think that there's not value here for you guys. So when I started thinking about that, I started thinking about another problem that we're actually having at Hippo right now. It's not really a problem, but it's something that I'm a part of investigating, which is how can we improve ad hoc conversation, right? Conversations that maybe start, or a thought process that is started by someone, and they want to be able to just like get that thought out there so that they can, you know, maybe get feedback or other things, and then just continue about their day, right? And it's kind of the same thing with the stream here. We very often investigate things, check things out, try things, and then that's it. And then I basically just go like, okay, check the VOD. And I don't want to do that anymore. I want to be able to give you guys more than that. So over the weekend, I found a really cool piece of software that I've known about for a little while now, but I've been thinking about using more and more. And the whole point of this software is that it allows myself really, to have a place of putting all of this information, all of my ideas, anything that I'm really working on, and share it with you guys. And not only that, allow you guys to become a part of the conversation as well. Do you write blog posts about engineering? So Pravan, let's hold on. Just give me a second. Yeah, we're going to get there. We're going to get there. Because I didn't want to also just like write blog posts. I'm not a blogger. I'm not somebody who creates blogs. What I do is I create a bunch of documentation, right? Like I create more of like Wiki style information and content when it comes to like, knowledge sharing and stuff like that. And so when I thought about that, I started thinking about, well, what would be cool that would be like kind of like a wiki style approach to where I could, like, my goal with this, just so you guys know, is to just really be able to knowledge dump. That's it. I just really want to be able to be like, okay, I want to take this piece of information and put it on the internet, and if anybody else can use it, then cool, anybody else can use it. And if they can't, then that's fine too. But yeah, the main goal for me is to make it just so that that process is easier for me. I can't write a blog post that way. You know what I mean? Like I can't, like if I write a technical document and I want to be like, oh, you know, I'd love to share that technical document with people. I can't, like, I don't want to turn that into a blog post. You know what I'm saying? Like I just want to just like be like, here, see if you can understand the technical document. You know what I mean? And that was the challenge for a while. It was like, well, how do I approach this? So even with something like this, right? Like all of these, like how do I easily turn this into a document, you know, for you guys to be able to talk around and have conversations and reference later on. And I realized that it was really something more of like a wiki approach. And so when I did a little bit of investigation, I found this really cool piece of software called Discourse. Now Discourse is completely focused on building a community around conversation, a community around discussions and working together and things like that. And I really, this has been on my radar before. This isn't the first time I've heard about Discourse. I've run like blogs and even wikis in the past. So I've always been like, okay, you know, on with like what basically isn't WordPress. And Discourse was something that popped on my radar a while ago. Now they have a pricing system, which is like kind of expensive. But they do provide you with the ability to using their own software and deploying your own Discourse instance if you wanted to. And that was something that I found really interesting. If we go here, for example, there should be a demo somewhere. Well, see, this is why I'm doing this. So let me see if I can show you guys, like, where's like a demo? Here we go, demo. So this is really like, if you were to ask, like, what does Discourse look like? It really looks like this. You can get like nice little themes and stuff like that, but really this is Discourse. And it really is a wiki-based forums where it allows people to come in and have conversations about things, share conversations, like have more of like in-depth discussions, like you could review things and post about that, whatever. But this was like really attractive to me. This was like, oh, okay, I like this. This is something where I could post this when I wanted to, and I didn't have to care if anyone saw it or not. You know what I mean? I just post it, like whatever. And so when I thought about it, I was like, well, is this something that we would want to do? It actually did align with a lot of our goals. It gave us the ability of having things like categories and, you know, people could sign up and, you know, have a part of this conversation. And also it seemed unique, you know, in all seriousness. Most of us today are looking at, you know, Stack Overflow mostly for solving problems. But remember, I'm a DevOps engineer. My job is to figure out how to improve, you know, how developers work together and communicate as well. And this seemed like a really cool tool for us as a community to share and have conversations around. So let's go back to this really quickly and ask ourselves, how can we have a conversation around this with something like Discourse? Well, it's actually pretty easy. Discourse is powered by Markdown, right? And if you notice, if we go back here, I've been doing a lot of writing in Markdown, right? And so basically what I'm going to do is I'm going to be writing notes and taking notes and you know, sharing all of these things. And then I'm going to make them into Discourse posts and I'm going to post them on Discourse. And I did that. Basically, I created a Discourse for us that I'm going to share with you guys now called ALT-F4.wiki. And I'm going to post it here for you guys too. This is the official ALT-F4 Discourse or ALT-F4 wiki that I've decided we're going to host ourselves. It's in the garage. It's in the data center. I set it up a couple days ago. And I started adding content to it as well. And I think one of the things that's really important about this is that you guys feel comfortable that you can add content too. It's going to be moderated. We've already got our mod team knowledgeable about it and signed up. I'm on it as well, so I'll be moderating it too. But the thing I really want to point out to you guys is you can sign up and start contributing if you want. So let me show you a little bit of what I contributed and see if maybe you can get a better idea of how you can too. So right now, I've set up a very simple category structure. Now, there's some things in here that you guys won't be able to see, like staff stuff. But most of this you will, like technical design documents, DevOps and infrastructure, site feedback, Twitch streams, software development, all of that stuff you'll be able to see. But I really do want to make sure that these categories aren't super vague, because like technical design documents versus like software development, this is a way more targeted category versus something that's just like super out there and just could talk about anything. To give an example, the technical design documents category is focused on literally helping you get better at writing technical documents. If you've ever found yourself in a scenario where you've been like, I want to get better at writing these things down and, formulating my thoughts and putting together like a better process and stuff like that. No, we didn't. It's for some reason there is a, what's it called? There's like a database hook that happens sometimes. I don't actually think it is. Did we really just break it? Oh, it might have. That's fun. Is somebody being a jerk and like actually hitting it incredibly hard? I'll take a look at it in a second. Here, let's look at it now. If one of you guys just did that, you guys are freaking annoying. Discourse. Ooh, hang on. It kicked. It's actually fine. It's distributed. It is in Kubernetes. It's right here. So you guys can't do that much damage. If anything, you just like poked the instance, but it's actually restarting. I love Cloudflare tunnels. They're super nice. Let's give this a second to restart. I don't really know what just happened. Wouldn't use it for enterprise? Nah, I mean, no. You'd pay for the tunnels there. But anyways, the goal here is to make it so that I can make all of this into posts for you guys. Now, as you guys noticed, I have not tested at all throughput, so I guess I'm gonna have to see what that's like. But yeah, that's really gonna be the goal here is that I'm taking all of this content, I'm putting it on the site, and then I'm making it available to you guys. All right, let's see if we're back up. Not yet. It looks like it's trying. Did you deploy it with Pulumi? Yeah. It's called Discourse. It's completely out of the box. I've not tweaked it at all, so there's a solid chance that I need to like give it more, I don't know, something. Look forward to shit posting and learning. I mean, hey man, as long as you learn, that's the biggest thing. Let's see what is happening though. Okay, there we go. All right, we're back up. Would you like to reconnect, please? Worked for you? Okay. I don't know anything about hosting a discourse, so this is a new experience for me as well. I mean, it's in a Kubernetes cluster, but I don't know. It shouldn't be like this hung up. I will say that's a little odd. Try it over here. Did it work for any of you guys as well, or it's still hanging? Let's go to. Oh, it died again. Trying to register with GitHub. Okay. Yeah. Let me hold on. Huh. Perhaps out of memory. Yeah, that's actually what I was about to look at. Let's see. Worker 2.4.092.124.088. Nah. Unless it's got memory limit. There we go. Okay, there we go. It's loading for me now. Try now, guys. See if it works for you. Thanks, oh Thug Muffin. I appreciate it. I mean, no, actually, what I need to do is I need to just go to the Helm discourse chart and probably read the configuration more. That's probably what I actually need to do. I wonder if they have any like limits or anything like that. Replica count, number of discourse inside. Oh, dude, it's taking 10 seconds. Why don't we scale this out a bit? It's only got one replica. Why does it only have one replica? Node selector tolerations. Yeah, there'll definitely be a bit of latency, but it wouldn't be 10 seconds. If it's 10 seconds, that's more the service than you. I'm purposely not showing all of your guys' GitHub tokens. Yeah, no, that's why I'm doing it right now. I think what we're going to do is I think we're going to up the replica count. Let's do that. Let's go to cluster on-prem. I don't have anything in here that I should be worried about, right? Oh, yeah, maybe just like my origin cert. MV origin cert. Let's move that out of here. Anything else in here that I should be nervous about? Setup. Ah, yes, the setup as well. All right, we're good. Okay. Without GitHub auth. Yeah, there is. We'll talk about that in a second. I wanted to talk to you guys about that before we did it. There is. I can enable it. I just don't know if that's going to be a good play. That's my main thing. Access to the form is invite only. Okay, cool. That's fine. All right, let me hold on. I appreciate you guys helping me. Let's do this first. Let's up the replica count. So let's go to the discourse thing here. Is it just replica count? I think it is. So values, element OP. I want to talk to you guys about sign-up options because I want to make it so that you guys can have access to it, but I also don't want to make it so that it's just like a nightmare. This dude making changes without a ticket. Oh yeah, whatever, man. Okay, replica count. I think this is okay, right? Readiness probe. Exists pod labels, node affinity. I think that's good. Sidekick. Yeah, let's just do replicas. I like that. Give it some more pow pow. I have a bad feeling that this thing needs to be like horizontally scaled by like a bit. So let's just do 3 for now. Let's see what that looks like. Update. Has a ticket been raised? Tell you what, if we ever get to that point to where, okay, so let me log in really quickly. Okay, so I'm logged in now. Let me go to admin. Man, this thing is slow. Holy smokes. Never mind, we're good. I can show this. Yeah, it is very slow. I wonder how many people are on the site right now. It was fine with 1 person. That's crazy. Like, I mean, I hope a lot of you guys are using it, but no idea why it just like so wonky. Okay, let's do this. We're gonna open up another one of these guys. I'm escalating the hobby. Well, what's cool too is like this is something I actually want to I do want to propose us use at Hippo. It is something I would, so us testing it here would be good. Okay, so we're going to go from 1. There we go. 2 more. So it looks like it goes. So it's a sidecar and the instance itself. Internet preferred over Slack. That's kind of what I was thinking. I love that you guys are all in dev. Like, I love that you guys are all like, all right, let's talk ops shit. I've missed you guys. Oh, hey, did you guys see that our YouTube video's out, chat? Look at this. Look at this. So if you do the ALT-F4 stream, just Google that or YouTube that. What in the world? That is. Oh, I didn't spell it right. The ALT-F4 stream. I didn't spell that right. There we go. Look at this, chat. Our first in our series of the Azure stuff got released. And it's already got 2,000 views since February 1st, which is pretty crazy. I wasn't expecting that. But hey, look, it's me. Yeah, if you guys haven't seen it, if you guys don't recall, we moved to Azure a while ago. We moved Quirk to Azure a while ago, and we did a whole video on it. If you guys were ever wondering what was going to happen to it, there it is. It's right there. It got released. It's on the YouTubes. Did our deployment go successfully? Wait, what? Interesting. Thank you. Huh. Yeah, except for the container hasn't even created yet. And I think I know why. So if it's working snappy, it's just because it's maybe it needed a reboot or something. I don't know. But persistence. Image stores data, bitnami path. Persistent volume contains. This is known. See the parameter section to configure or. Okay, so here's the problem, chat. You Kubernetes nerds out there. These aren't mounting because there's an affinity right now or something with the storage to where it can only connect to one container at a time. And I don't know how to disable that or change it. Extra volume mounts. How do you change that? Storage class, access mode, read write once, size, select type, rolling update. Oh, it's not even gonna be. All right, let's see. So basically what's going on, chat, is these containers aren't starting because... Oh, here, let me see. Okay, look at this right here. Unable to mount volumes. Waiting for condition. Attach. Volume is already used by pod discourse. So I don't know why, but for some reason, they're not letting it like scale out replicas for some reason. So I need to figure out how. I think it's just a setting I have to change so that it will allow other containers attached to this volume as well. Replication. Here we go. This chart only says this. Should you want to increase the number of replicas, you might want to follow these steps to ensure create a conventional release that will be scaled later. Okay. Whatever. Discourse password. Discord password. Sidekit. Discourse skip install true. Oh, here it is. Here we go. Okay, so only deploys. Okay, if you have already initialized the database, you may want to create a release with a desired number of replicas. Remind to set discourse skip install to true. Interesting. Okay, hold up, guys. Hold up. I want to fix this really quickly. Discourse. So discourse skip install. Discourse 27. I will answer your questions. Just give me 1 second, guys. HIJK. Yeah. Skip install. True, right? Yeah, true. True? Where did you go? I was just looking at you. Oh, how dare you? Persistence. Bring me back to where I was before. Documentation. God dang it. We're going to get this working. Okay. Skip install. Camel cased. True. Yep. That looks good. Okay. Create a conventional release that will be scaled later. Wait for the complete. Perform an upgrade specifying the number of replicas and the credentials used. For this to work properly, you need to provide read, write many PVCs. If you don't have a provisioner for this type of storage, we recommend that you install an NFS and what? If you don't have a provisioner for this type of storage, we recommend that you install the NFS provisioner chart and persistence 10 gig and map to a read, write. Crap. That sucks. Whoa, crap. I don't know. VMware, VMware, vSphere, Kubernetes. I might have to reprovision everything. Oh, that sucks. It's not terrible, but I need read, write many volumes, and I think I'm only getting read, write only volumes right now. Yeah, here. Hold on. Just give me 1 second. Come on. Where is it? Here we go. Okay, so this is discovery. Data centers, CPI secret, all nodes tainted, display manifest, install storage policy. Yeah, we've got a storage class. Okay, here we go. Is default. Kubernetes read, write, many. Claim. Can I change a claim on something? Expanding, reserving, types of persistent volumes. Claim policy. Okay, let me catch up with chat. When you said you wanted to implement it at work, did you mean full ITL, or did you just mean some more formalized management of incidents? Oh no, this would just be for all internal documentation. Yeah, this would it would really be more of like a developer forum than anything. Where you guys can, well, I mean, internally would be something that I think everybody could go to and share knowledge, things like that. It would be like outside of Confluence in the sense of it would be more focused on conversations, I think. Versus like at work, or I'm sorry, versus here, what we're doing is really meant to be just like anything, anything that you would want to share. I need to figure out how to change. Can I change? Binding. Storage claim name, volume name, claim ref. But I thought, isn't it like a setting? Here we go. Access modes. Okay. That's what we need. We need this access modes thing. Please tell me they have this. Access. Ah, there we go. Ah, okay. So we need to change this as well. No, don't you dare. So, oh my gosh. Access mode. Okay, you see this persistence access mode here? This needs to be not read write once, but read write whatever they said, many, right? That's why these aren't mounting. You see how these are just that container creating? We haven't actually mounted anything yet. That's the reason why, is just because it's only allowed to write to the volume once, so it's only letting one container access it. So thankfully they did make it an option in the chart. So if we go to, again, access mode, we can see it's persistence.access mode, read write only, or read write one, read only many, read write one, read only many, read write many. Yeah, so we want read write many. That's the one that we want. Okay, let's give this a shot. So this is going to go into persistence. So we're going to go here. Oh, geez. Why did that do that? 3 more. Persistence. Oops. So what are we doing? Just so anybody is not aware. Basically, we're trying to get the brand new ALT-F4 wiki fully up and running, so that you guys can access it, get signed in, all of that good stuff, become a part of the conversation. But when I first showed you guys, you broke it. And so, we're scaling it out. We're fine tuning it. We're making sure that more people can use it. And so, yeah. The first part is giving it more replicas, which is making a couple other things I have to do here. Read write many. There we go. Read write many. Read write many. Register request too thick. Yeah, it definitely apparently has some very thick requests. Here's the thing though. I don't know if this is gonna make the claim be reclaimed. If it does, then I have to reset the whole thing up, which is kind of like blah. Not the end of the world, but I'd probably want to download my current, I've got like 3 or 4 articles. Hopefully not. So it's got to replace the volume claim, replace the config map, and replace, but it's just the claim. It's not the volume. Okay, so it's not the volume though, right? So it's the persistent volume that would be deleted, not the claim. I don't know what's going to happen. Let's do this. Let's do a quick, can we back up? Is that like a thing that you can do? Let's do that. Discourse backup. I hope it's easy. Oh, look at that. That's like very easy. All right. So here. Okay. So here I am. So go to the admin, click backup button. Backup. Do not include up. No. Yeah, we'll back up. I guess we're just waiting for it to show. My worry is that the volume claim might delete the volume. There we go. It won't? You don't think so? Well, but the volume claim is on redeem, right? That's why I'm worried about it. I guess that's the only reason why, is because the volume claim is on redeem. So if the volume claim has to be replaced, won't the volume go with it? I mean, it doesn't matter here. I'm about to download the backup anyway. A link of the download has been emailed to me. Seriously? That's what I thought. I was like, I'm pretty sure that's how that works. I mean, what we could do. Where's the BB form install? No. We're gonna keep this. I really like this a lot. Let's do one. There is something else we could do here, which is we could change the policy, right? We could make it so that the policy persistence, right? So they claim use an existing PVC, which must be created manually before bound, access mode, size, selector, type. Node affinity, hard. Oh, I guess maybe you can't change it. Oh, well, it's backed up. We could try it. Let's see what happens. Let's try it. Whatever. we need it anyways. Like it has to be done. It doesn't really matter. Let's do physical PHY physical. Oh, wait. Let's do this. Physical. Oh my gosh, PHY physical. Wait, what? PVC. So here's our PVC. Well, no. Oh, it hasn't run yet. Never mind. I was like, I don't see anything yet, but there's our persistent volume claim. There it goes. PV. I don't see any physical volumes getting deleted though. Yeah, look at that. The volume itself is still there. See? So I think we're good. Well, it's still terminating the... I wonder if that's because... Let's do this. Let's just help it a little bit. Let's just help it a little bit, chat. We're gonna help it a little bit. We're just gonna scale that down to 0. And we're gonna let that container, we're gonna let those containers just go. Just jiggle it. We're just gonna jiggle it a little bit. Let's go back to PV. Discourse data. No! Oh, it's still there. Okay, cool. Wait, well, what was just deleted though? Discourse data. No, it got deleted. Yep, it's gone. Okay. Yeah, it got deleted. Yeah, it went away. Well, we know that for sure now. PVC. I had to let those containers die though. Okay, so we're pending right now. Why are we pending is my question. Oh, because we're persistent. We're pending a volume claim right now. Interesting. Discourse Redis. So the data for, okay, interesting. I don't understand why. I thought you were going to show. I showed it to you for a second and then I deleted it. Come on, you guys know how this DevOps stuff works. No. I'm going to show you. Listen, I'm not just showing you you know, what's it called? I'm showing you how you can also manage it in the circumstance where something like that. We backed it up. It's not that big of a deal. Although I am like very curious as to why this is pending for so long. Okay, I know why this isn't working. I know why this isn't working. Okay. My vSAN class cannot support. My vSAN class cannot support read write many. Okay. We could still get around this. I did. I already viewed them. Yeah. The error is, the reason why it's not working right now is just because, yeah, it doesn't support read write many. So here's what we're going to need to do. NFS. Yeah, I think we're going to have to use an NFS approach here. Now, do I have an available NFS server is the question, which I don't think I do. Well, you know, do I? I have iSCSI. NFS, storage class, NFS. Persistent storage class, PostgreSQL. Interesting. So, oh, yep, no worries. I'm not going to deploy a whole cluster. You're crazy. Guess what, though, chat? We have something fun now that we can do. Do you remember how I told you guys that you need to get better at writing your documentation? Well, chat, let's do it. We're going to write a document for solving this problem. So let's do this. Page. And then we're going to call this discourse distributed deployment. Right? Problem. We are unable to replicate discourse. No, this is the real problem. The problem is when giving discourse more than one user to access the wiki, it crashes. This is because by default, discourse Helm chart only deploys one replica and sidecar for the service. That's our problem. We need to properly replicate and scale out discourse using storage that allows for read write many volume claims. So that's the problem. Let's say our existing volumes. So we're gonna do this. We'll say we use vSAN. We use the ALT-F4 LLC data center Kubernetes cluster, since technically is all that's proper next. Kubernetes cluster is integrated directly with the vSphere vCenter. Wait, no, with vSAN. VMware vSAN for remote physical volume allocation. This allows our K8 cluster to mount highly available and distributed volumes across multiple nodes. This is great. However, for us to replicate discourse, we need to enable read write many PVC, or we need to enable read write many on our physical volume claims for services, which is not supported by vSAN provider. Yay! Cool. So the problem is, we could say, what is our problem? And then our existing volumes don't work because we can't use read write many. So read write many options. First one obviously is going to be NFS. I think that's the one we're going to go with. Let's do this really quickly. Can you guys do me the favor of being super awesome streamer, community, follower, member peoples, and let me know? I'm going to take a super fast break here because I've been going for like an hour and a half. Can any of you guys do any research and see what are our other options when it comes to read write many volume allocation support? Right? So NFS makes sense to being it, or NFS makes sense for it being read write many, right? Because it's a distributed volume management. It's, it's networked. Anything can access NFS and write to it at any time. So it's that makes sense. If you guys can think of any other solutions out there besides NFS that support read write many, yeah, let me know. I'm going to take a quick little break here since I've been going, again, almost for a solid I have been going for 2 hours. First things first, I want to say thank you all for hanging out with me today. I appreciate it. I've missed you guys. If you are just tuning in, we are launching. I say launching because it was launched and then you broke it. You broke it. No, I'm just kidding. We launched a brand new community project that I've been really excited about called the ALT-F4 Wiki. It is powered by Discourse and essentially powered by you guys. It's a forum that we are going to host and maintain. Our community is going to host and maintain it. It's going to be hosted in our garage, which is what you guys see right here with all of our Kubernetes persistent volume claims, I guess, at the moment. But yeah, it's going to be a place where you guys can go, as well as myself, and really just do a knowledge dump. If there's something that you found interesting, go share it. If you have a question, go ask it. The point of this is just to take the already existing community that we have in Discord, as well as like in chat and all these other places, and make it available to you guys. And so we're deploying that right now. We already had it deployed, but then, like I said, you mother broke it. But no, we're actually making it so that it's more highly available. We're scaling it out. And, you know, as always on this channel, you're seeing how I deal with DevOps on the daily. So thank you guys. I'm going to take, like I said, just a quick break here. If you guys don't know why I also run ads during our break, that's why. If you're new to the channel, be sure to check out that. And again, our Discord and stuff. So yeah, give me a brief minute. I'm going to take a quick little break. Again, we're probably going to go with NFS, which means that we're going to have to deploy an NFS server. I'm not entirely sure if, I don't really know how we're going to do that. Yeah, I don't know if I just want to lean on something that already exists or deploy my own NFS server just for this. I don't know. We'll see. We'll see. We'll send you a meeting invite to the PIR. Cool. All right, Mr. Yan. Everybody, I will be right back. Aramis, what's up? Hello, hello. I didn't miss you. I didn't miss you. But yeah, I will be right back, guys. Did you check out Rook? Did you check out Rook? I've never used it though. I've never checked that out, Keanu. I don't know what that is. But all right, give me a second. I will be right back. Be right back. See you guys 1 second. Yo. See, wasn't gone that long. Okay, so yeah, wasn't expecting it to break right away. God, I love my job. Okay, so what do we want to do? Did anyone get any information on if there was any other persistent what was it again? So let's say Kubernetes persistent volume read write many support. How to set up read write many persistent volumes. Is that what you, I'm sorry. You were talking about Rook. I've never heard of it. Is that what Rook K8s? Production ready management file object storage. I see. But what does this do? Does this provide NFS to my NFS? Wouldn't this just create NFS mounts for me though? Sorry, chat. I don't mean to blind you. NFS operator. NFS administration hook or admission hook. We don't need that. NFS operator. Okay, so CRD is in the operator. Okay. Create and initialize an NFS server. Oh, here we go. Okay. Cluster role. Cluster role RBAC. Persistent volumes. Persistent claims. Policy. Cluster role. Well, that's all RBAC. Okay, so this is just namespace and RBAC stuff. Here we go. Okay, persistent volume claim. So Rook NFS for volume claim of 1 gig. Okay. And then, so what is the backend to Rook? Right, like Rook needs a backend. You can't just deploy it. So what is, yeah, like it says the CRD is in the operator. But like where are the volumes that Rook creates going would be my question. Namespace, API group. It's got its 3 main examples. Default storage class. Oh, okay, I see. So it's using the default storage class here. First example, we'll create that is backed by the default storage class of the environment you have to be running. Some environments, this could be a host path, and others, it could be a cloud provider virtual disk. Either way, this example requires a default storage class to exist. Wait, so does that mean that Rook can create claims off of, like, could I create a, okay. So the idea here basically is that I deploy this. This will give me NFS servers, and then I mount discourse with this. I think this is just too complicated for what I need right now. I like it. Like, I'm very interested, but I just need an NFS mount point at the moment. I don't know if I want to necessarily try and solve for the distributed, highly available thing. Although I do really like this. Like, I will probably end up using this, honestly. I'm curious to know, like, could I use, if I could use the vSAN, yeah, probably I've used it myself, but I mean, the thing that's really attractive about this is that, like I said, I understand that, if you guys have worked with Kubernetes before, you've probably heard of CRDs or custom resource definitions. That's very common. And then deploying an operator, that's also super common, right? These are very, very, very straightforward, which makes sense as to why it's supported by the foundation. So, getting the CRDs, deploy the operator, that all makes sense. right? But then when we talk about like, okay, well, what is it using, right? Like that, it doesn't really say much about like what is like when it goes to create a NFS server, right? For example, what is it using to create that NFS server? Like, what is the backend for where that data is going? And so that's what I'm just trying to wrap my head around. And so you can see here, like OpenShift create security context. That's just a security context. Pod security policies. That's fine. We don't need to worry about that. That's again, this is recommended but optional. And then create and initialize an NFS server. Now that the operator is running, we create an NFS server by creating an instance of NFS rook IO instance. Various fields and options, NFS resource can be used to configure the server and its volumes to export. Right, so this is all RBAC. Nothing has anything to do with resources here. And then they say this guide has 3 main examples that demonstrate exporting volumes with an NFS server: default storage, XFS storage class, and rook ceph volume example. So the vSAN is the default whatever. The vSAN is the default. Here you go. A default storage class must be present. So this persistent volume claim right here, this would enable me to use vSAN if I wanted to, but I'm in a chicken before the egg scenario where vSAN does not support read-write many still. It still doesn't support it. So even if I wanted to use vSAN as the back end here, this is what I meant, Keanu. This is kind of what I meant before, is like, I don't know if I would use this here. Here's why. Right, I need a lower level thing to provide, access to my volumes and other things like that for data, right? And I want to use NFS for that. Right now, the only backing volume provider in the cluster is vSAN, right? vSAN is this right here. It's my actual vSphere cluster. Right? That provides volumes to the Kubernetes. So the actual cloud cluster is providing volumes to the Kubernetes cluster, if that makes sense. And so, yeah, so exactly, Schmiley. That's exactly it. vSAN doesn't support read-write many. It only supports read-write once, or read-write only, or whatever it is, right? Read-write once. And so because of that, if I wanted to use vSAN, like anything that wants to use read-write many, I can't use vSAN as a backing storage. Now what I could do is I could create like another storage that Kubernetes could use that is lower, right? And then use the NFS rook stuff on top of that, which is probably okay. But I don't know where that data would exist. That's kind of the challenge. Is like, where do I want to put this data? Where should the data exist? Right now, data exists in 2 locations in our data center. The first is within vSAN, which uses vSphere to replicate data across multiple hosts and hosts using network and SSDs. So this is the first thing. The first is vSAN, which uses vSphere to replicate data across multiple hosts and networks and SSDs. Now, the thing about vSAN, the second is hypervisor drives directly on the host. So let's talk about vSAN for a second. vSAN. So vSAN is networked highly available storage that combines hard drives across multiple hosts into cloud storage for use with virtual machines and Kubernetes clusters, right? And this is what we use it for. We use it for our virtual machines, and we use it for our Kubernetes clusters. The limitation being that in Kubernetes clusters, it only supports read write once. And then the next one is physical disks. Each main hypervisor has about 1 terabyte to 4 terabytes of space on it that can be used to provision additional disk space. The downside here is that this requires virtual machines to create create volumes on these disks and mount them directly for use. So in the vSAN scenario, what vSAN does is vSAN will actually take our disks, join them all together, set up like caching tiers and all that fun stuff, and then make it just available, right? So for example, if I wanted to, if I go in here and then I go to here, right, you'll see that I have a vSAN data store in my data storage or my storage section. And you see I've got like 1.6 terabytes out of, I think, like 5 or 6 available, something like that. This is an actual mount point. This URL right here, ds blah, blah, whatever. This is the URL that my virtual machines use to connect to and mount volumes from this new networked storage. This same URL is used for the Kubernetes cluster, right? So when I say that the Kubernetes cluster uses vSAN as well as the virtual machines, they both use this DS whatever mount point and then mount volumes and create volumes inside the vSAN as necessary. So, you know, that's really nice, but I don't want to like add an additional layer on top of that. Like if that's as close to the metal essentially as we can get, then we want to be able to keep doing that. And so the other option, when I say physical disks, I'm talking about the actual hard drives on the system. And so you'll notice here that this has that same DS path, but instead of this being a type vSAN, this is actually just a VMFS6. That's because this is a physical hard drive that exists on one of these nodes that's just not being used at all. It's basically empty. There's nothing being used on it. And so if I wanted to, I could provision disk space to these servers as well. So the upside to this is I could be like, okay, cool. If I want to create a very simple NFS server and then just make it so volumes can attach to that and start using it, then all I need to do is create a very simple VM with what's it called? Disks with enough space, and then create that VM, format the disks inside of the VM, right? Install the NFS server, and then mount, my Kubernetes container directly to that. And I think that's what we're going to do. Honestly, I think that's what we're going to do because that's the simplest approach. What is the downside to this, though? And this is something important. All of the network storage, or all of the storage that we've talked about, and we could say the main downside, or the main upside to this, let's not say vSAN. So physical disks. the downside to using physical disk storage is that it is not replicated in any way. It has no fault tolerance or backup strategy. Strategy. Yeah. Okay. I still spelled it wrong. So that's the downside of using physical disks. Is basically with vSAN, we do have the support and the benefit of being able to of being able to lean on the replication of vSAN and all of that kind of stuff. But with physical disks, even though we get an additional storage boost, we really don't get any kind of replication. If the disk dies, the disk just dies. Like, that's just it. So that's just something to note here with this decision is later on, we're going to need to make a decision to fix that if we need to. Don't worry about the command wall. It's always fun. So, yeah, we actually had somebody, what's up, Kung Fu Me? How's it going? We actually just had somebody else recommend Rook. I took a look at it. I like it. Like, it looks cool. But Rook is doing the same thing that a lot of these other providers are doing, which is they're leaning on, here it is. They're leaning on Kubernetes pretty much fully, which is fine. But it depends on your Kubernetes setup on how well it works for you. What I mean by that is if I had a backend that gave me low-level networked storage that was also super fast, that was also very, could support read-write many. I mean, really, the only downside to me not using vSAN right now is it just can't do read-write many. Otherwise, vSAN is like perfect here. So that's one thing to kind of note here is like vSAN is actually a great solution for this for me. It's just I can't use it because it doesn't support read-write many. But when you deploy something like Rook, at least from what I could tell, it's going to lean on, all of the technology that Kubernetes provides, including like the back end of the storage for it. So, if you don't have good storage already, you don't want to put, something like Rook on top of it. Otherwise, it's just going to make it slower. And so that is the thing that I'm considering and thinking about here is I can't use vSAN, which is my only storage provider. Like here, look, guys, look, if I do storage class, I've only got one storage class. I can only create vSAN physical volume. So I'm in a scenario where it's like, okay, I either write volumes directly to hosts and just call it a day, or I, figure out another backend that is, networked at least and remote that I can manage. And that's kind of where I'm going, like, okay, maybe we'll just use NFS for now, create a simple NFS server, call it a day. Yo, what's up, Worka? Thank you for the 11 months, man. Appreciate it. Io Samuel, what's up, man? How's it going? vSAN also being accessible across the host. Yes, vSAN is awesome in that regard too, that it's completely networked. But yeah, Kung Fu Me, I hope that answers your question. It's an interesting solution, but it doesn't mean it's a one-size-fits-all solution. So, and again, remember, our goal here is that we want to get our wiki up, our brand new wiki that is now dead. So let's do that. Explain that again. It can't do read-write many. Okay. So read-write many. TLDR, if you have more than one container that you want to write to a volume, that is a read-write many scenario, meaning that the volume will be written to by many sources. You need to be able to have a storage class that can handle many different locations writing to that physical volume at the same time. If you were to say like, well, can't just like anything read-write any? No, it looks like it might, but it actually is going to do things like deadlocks or other things like that to wait for those other writes to finish before the other ones can. In a read-write many scenario, it knows how to handle all of the writes simultaneously and can actually synchronize them effectively. So vSAN is great. It's networked volume. It's integrated into our Kubernetes cluster, right? I've got all of that stuff right here, right? Networked, highly available storage that combines drives across multiple hosts into a data cloud storage for use with virtual machines and Kubernetes clusters. The limitation being that Kubernetes clusters, it only supports read-write once. So even though it's networked, it doesn't actually have the same protocol support like what Orca just said of NFS or SMB, Samba, where it can write multiple things at the same time. And so in this case, we can't use it, although it's networked and highly available and all those other really, really cool things. The only other option we have to us is these physical disks. And this is what I was telling you guys, where these disks exist inside of each server, right? I've got a 2 terabyte physical disk in it. I've got a 4 terabyte physical disk here. I've got another 4 terabyte physical disk here, right? Like these are disks that are just sitting there doing nothing, right? So I can allocate to these. Now, the thing about this is if I allocate to these, they're not highly available, right? I'm just going directly to that server, putting a VM on that server. If that server dies, the storage goes down with it, which is kind of a bummer. And it's not replicated, right? So it doesn't, like, if I lose the data, it's also not available somewhere else. It's just on that disk. So that's another thing to kind of pay attention to. Now I have right now, I think really just one hard drive left available anyway. So I don't really have space for any more replication, meaning replication's kind of out of the question. If we had space across each one of these drives, I could at least like create 3 instances and then like replicate them that way or something. But I think what we're going to do for now is just create a good old-fashioned simple NFS server, and then use that in the time being. Yo, Kung Fu Me, I'm surprised as well, dude. And somebody asked, are you using a Tanzu Kubernetes cluster? Yes and no. I have the cloud. So the Kubernetes cluster itself is initialized with the VMware cloud provider. So if that's all it takes to be a Tanzu cluster, then yes, it is a Tanzu cluster. But I don't have like all of the bells and whistles of the licensing. I'm using the open source provider, cloud provider. Yeah. So yeah, I'm just using whatever allows me to integrate with the Kubernetes. Wait, what? Oh, okay, cool. Tanzu Community Edition is free. Oh, is it really? I didn't know that. vSphere 7. No license required. Bang. Orca. He just shut you down. I'm just kidding. Okay, so let's do this really quickly. Let's go to our host really fast and let's get a little bit of a understanding of where we are here. So yes. Okay, so I already have, and I've already actually done this. Should we write more documentation here? Okay, so hold on. So physical desk. Let's just do this. Note. Oh, can I not like make a note? Like, how do can I turn this into call out? Ah, there you go. Oh, I like that. Not replicated anyway. It has no fault source. Okay, cool. Yeah. Ooh, that's nice. I like that. Okay, cool. So let's talk about this. So discourse distributed deployments. What is our problem when giving? So if you guys don't remember, I'm going to recap everything that's going on right now. In the very beginning of the stream, in the very beginning of time, I talked to you about the first thing that we have changed that is new for you guys, which is we have a whole new stream setup, chat. We got a whole new flippin' stream setup. It's all new. Most of it is. The internals, at least. The computers are not. Well, one of them is. So TLDR, we got rid of NDI. We scrapped it. I wrote a whole article on that as well, right here, of basically no longer using NDI, why we got rid of NDI, all of that kind of stuff, as well as like how we wanted to configure the new setup and all of that kind of stuff. So anyways, in the first part of the stream, I showed you guys all of this. And I showed you guys all of this and wrote all of this documentation to unveil our new ALT-F4 wiki. It is a place where you guys and myself will be able to go to, write topics, talk about things, and really just share our interest in all the things that we work on. Excuse me. When I revealed the website to you guys, it broke. And that's probably because it's just like, it was a very small instance. So we needed to scale it out. We needed to add more replicas to the Discourse server so that it could actually work for you guys. When we tried doing that, we ran into the problem of realizing that we needed a write many or read write many volume to be able to do so. So we backed up the Discourse service, and now we're trying to redeploy it with this volume. So during this whole process, I've been making documentation on all of this, and this is really why I wanted to share with you guys why I'm making this wiki for you guys and for all of us. Is, as you can tell, when I actually have to, or when I try, I can generate a lot of knowledge and just put it on paper. And I think that we all can in a lot of ways if we really try. And so the wiki is really about taking these opportunities right here, where I might not make a YouTube video about this one weird issue or this one, like, okay, maybe somebody wants to deploy a Discourse distributed deployment. How do I do that? Well, here's a whole article on how I did it and how I went through the process of figuring everything out, right? Like, that's what the value is here for you guys. And I want you guys to feel like you can share that too. And so that's why we're making it so that you guys are also able to sign up for the wiki, write things into the wiki, have discussions, and we're going to moderate it. We're going to moderate it. Don't make me ban any of you. I was wondering, how do you deal with burnout, or if you've ever faced... Oh, yeah, I deal with burnout all the time. You just have to, you know, balance what you're interested in. And I do think you have to, you know, you have to give yourself time to relax and breaks. It's, you know, kind of look at you as yourself as like a muscle almost. You need to not over, you know, stress that muscle, which is you. Okay, so like I said, I think, okay, so we've got one on 3 or on 0.1, and then we've got one on 0.3. So that means that 0.2 is completely available for disk space. Are you using a chart for Discourse? Yeah, I am. Yeah, I'm using the Bitnami chart. Okay, so we have 3.64 terabytes available to us. Now, if I think about what I need left overall, this first node, I believe, has got all of its disk space allocated to it. We've got a terabyte here, and then we've got 2 terabytes here. So on R210 ESX03, if we go to its disk space, okay, so we only used... Okay, cool. So we have a terabyte still available on R61003. So we have a terabyte available there. That's good to know. Let's do that. So let's make some notes here. So existing disks, physical disks, and then we'll just say like R2 or R610 ESX01 has... or 03, sorry. 03 has 1 terabyte available, right? I think 2, yeah, 2 is completely empty. So R610 ESX02 is 4 terabytes available. And then R610 ESX03 has 1 terabyte available. Okay, so this is interesting. So we've got multiple opportunities here by just looking at the physical disks. We'll say hosts available disk space. So looking at this right here, we actually have something that's kind of an interesting opportunity. Not now, but maybe later on, which is, if you look, we actually have a terabyte across each node available to us. So a terabyte here, and a terabyte here. Meaning that if I wanted to make my NFS, say, like, powered by Gluster, or if I was like, you know what, I do want to deploy Ceph, but I don't want to deploy it with Kubernetes. I actually want to deploy Ceph lower end and then have Kubernetes use that as a backend, right? I could do that. So that's actually super, 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 super cool that that's possible. That actually makes it a lot more attractive for me to at least know what kind of disk space I should use. So here's the question, chat. Here's the question. Looking at this right here, if I say, okay, I need, I have 1 terabyte available on all 3 hosts or all 3 of these hosts, then if I create a 1 terabyte node for now, right? Say we use this one, R210 ESX02, and we say, okay, you know what? We're not going to take all 4 terabytes of this. What we're going to do instead is we're going to not touch 01 and 03. We're going to leave those 2 terabytes intact. And then we're going to grab a terabyte from 02 and allocate it to that. So that later on, if I need to, one, I could create a whole new cluster outside of it with each 1 terabyte of each node, right? Because I have 4 terabytes available on 02, and then create my Gluster cluster and then migrate to that. Or create any other cluster I wanted to. So I think what we're going to do is, let's do this. So we're going to say, where should the data exist? Where should the data exist? We'll call this the solution, whatever. Or proposed solution. So the proposed solution is going to be, we will need to create a 1 terabyte. We will need to, actually here, but let's say this. Future proofing. Yeah, let's do this first. So future proofing. To avoid, because we deal with such limited space with regards to disk storage, it will be important we put this data somewhere that does not affect other decisions we may have on storage later. Because we don't need to provide a full disk to a resource like we do with the Samba services, we can allocate a smaller amount, which allows for reuse later. Cool. Okay, so that's the other thing I kind of wanted to note here is that once we talked about where the data should exist, we kind of want to talk a little bit about future proofing. I mean, I don't know if future proofing is a good word here, but something along the lines of like future disk availability, right? Something like that. Something that just kind of says like, talk a little bit about the future disk availability, because we have to think about that. So in our data center, we have in a lot of ways like maxed how much space we have available to us. We can buy bigger hard drives, but with that might come migrations, might come downtime, other things like that. So it's not the best scenario for us to just be like, whatever, and just figure it out later. It is a good idea for us to say like, okay, let's take smaller chunks and make sure that we can reuse these disks later if we need to, or add and allocate more space and stuff like that. So for us to be able to say, disk availability, because we have so much, limited space, we really need to make sure that we, don't give the whole disk space available to this service, that we only give a certain amount. Okay, so we don't need to provide a full disk to the to the NFS service like you do with the Samba services, because we do with Samba. Samba, we give the full disks available. Okay, so we will need to create a 1 terabyte hard disk, which is attached to a virtual machine provisioned in vSphere. This machine will need to be automated by Pulumi, and this machine will need to be automated by Pulumi, and we'll just say will need to be automated by Pulumi, but does not need configuration management, as this will not be our final solution. And what we'll do is we'll say alternative solutions. The ideal solution would be to provide some kind of replicated and highly available NFS storage for our Kubernetes clusters. Though this is outside of the scope of our current problem, the next time we deal with this, it will need to be investigated again. To provide the possibility of a future solution alongside our current implementation, we can set up the proposed solution with smaller and simpler parameters that can be migrated. For example, we only need this service to provide us with NFS mounts. That should be the only opinionation Kubernetes cares about. That means that we should be able to move our NFS backend entirely later and not affect deployments. So yeah, that's what we're gonna do. And we're actually gonna take this and we're gonna put this all above this, so that we talk about alternative solutions first, and then we talk about the proposed solution, so that it's understood. Why don't we take other solutions, and then we go, okay, well, that makes sense. Okay, are you familiar with ADRs? I am not. Architectural design records. Is this software design? Oh, no. Oh, nice, Lycan. That's cool. Hell yeah. Okay, cool. So that being said, I think we've got another document that is ready to go onto the wiki once we make it available. So let's do that. So now we know what we need to do. We need to create a 1 terabyte hard disk, which is attached to a virtual machine provision in vSphere. This machine will need to be automated by Pulumi, does not need configuration management, as this will not be our final solution. It it will need to provide unauthenticated NFS mounts for Kubernetes services. We can have a generic mount that all services use. I think for now that's fine. I don't think I need to like say like, okay, use this mount and this mount and this mount. We'll just have one mount that that services use with their own standardized path. Yeah. So, and then we'll say like, for example, the mount path would be like something like NFS dot, or we'll say, the other question is what data do we want stored on this NFS? Right now, we just want to store discourse data. So how do we deploy it in a way that we say like, okay, it's just for, well, this specific volume is just going to be for Kubernetes. So I guess we could just do like NFS dot ALT-F4 dot domain slash, and then the mount point would probably be, you know, data, and then slash service in this case would be like discourse, right? Or we would say service name like that. Volumes, maybe? Yeah, volumes. I think that makes more sense. So ALT-F4 domains, volumes. So we'll have a volumes mount point, I think is what we'll go. It will need an authenticated. We have a generic volumes mount point that all services will use with their standardized path. Yeah, exactly. That works good. I like that. That looks good. Okay. So chat, it's, you know, again, what I'm showing you is very, very common for, you know, getting to a point where you start not just jump into a problem and try solving it directly, but you actually sit down and before you do anything, you write everything out. You start taking a look and saying like, okay, like how is this supposed to work? And sort of, oh wait, hold on. You know, how is this going to work? How will it interface? How will it affect, you know, future business decisions, like stuff like that. So this is another reason why I'm sharing this kind of documentation with you guys in the wiki, is so that you guys can get more of a, you know, a bird's eye view into how all this works. Is that Notion? Yeah, I write in Notion and then I just copy it over into the wiki. Proposed solution. We'll need to create a 1 terabyte hard disk. Yeah, I like this. Okay, so let's do this. So now that we know what we need to do entirely, let's go ahead and actually create this. So we do have automation in here. It's our virtual on-prem automation repository. And if we go to it, if I do Pulumi refresh really quickly, it should refresh from, there you go. So you see all like the virtual machines and all that kind of stuff, all of this coming in. This is all information from vSphere. See, vSphere, 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 vSphere. This is all vSphere. So let's just go ahead and refresh our vSphere state. We'll do a Pulumi update. Hopefully there's nothing like that is like asking for updates. There shouldn't be. You can see that it also runs a lot faster. That's because, yeah, no resources unchanged, or no resources changed. Perfect. You could tell that it runs a lot faster. That's mostly also because we don't have as many resources in vSphere. It's, you know, a lot smaller deployment. Okay, so here's what's interesting. Every tier in our network is its own, or I'm sorry, every tier in our cluster essentially is its own network. And what I mean by tier is really like, you know, I guess logical scope is the easiest way to put it. So in our like data center here, basically, we have our folders that we kind of maintain everything with. So I've got the control plane. If we click on that, we'll see that it's actually my vCenter instance that helps run the whole vSphere cluster. That's because it's in the control plane, right? We have our game sphere, or our game center or I'm sorry, our game server folder, which has all of our game servers. Again, Arc, GTA, Minecraft, Rust, Valheim, all of that. We've got our Kubernetes folder, which has all of our Kubernetes instances in it. So you'll see like all of the system nodes, the worker nodes, right? All of that stuff. Excuse me. And then the same thing for Samba, right? Samba's got its own thing where we replicate and create multiple services. So with each one of these folders comes their own network. As a matter of fact, if I go to like system 01, you're going to see that it's 192.168.1.32, whereas Samba is on 192.168.3.8, you know. And so every one of these has their own network. So if I want to follow the pattern that I've already standardized, I'm not just going to create the virtual machine, but I'm also going to have to create the network that it exists on. So we'll just say we will also need to create a new VLAN for NFS services to exist on. The reason why we do this is because then I can scale out one service and not really worry about how many IP addresses it allocates, at least up to 256. So for example, I can have up to 256 Kubernetes nodes in my Kubernetes cluster. And that's because my current subnet is available up to 255, right? Same thing for Samba. Samba, I can scale out to 255 servers. So basically what I have said is I want to make it so that every service can scale out individually up to 255 times. That's like my full hard stop limit, right? And so I do that with all of these services so that I have that type of scalability even on the networking layer, and I don't have to be worried about it. So having an NFS one as well is going to be important. So let's go ahead and, well, again, we'll add that to the documentation. We will need this will allow us to create other NFS specific services in the future and isolate that traffic accordingly. So yeah, is that Notion? Yes, I use Notion. TLDR, since you are also a Confluence user, can you quickly give the pros and cons between them? Seems like Notion is a lot of traction, is a big competitor to Confluence. I don't think so. I don't think it's a competitor to Confluence in the sense that Confluence handles it from like a massive organizational perspective where they have like tons of other plugins and add-ons and features and stuff like that. Notion is just like bare bones. I think that's why it's getting a lot of traction, is because a lot of people like how bare bones it is. But there's like 90,000 things I can't do in, Notion that I can do in Confluence, and vice versa a bit. But I would say most of what Confluence can do, Discourse can't, versus what Notion. What like Confluence can do a lot more than Notion can, and Notion can pretty much do everything that Confluence can. Now, does that mean that, it's better or worse? That's up to you. I use each for, again, any kind of like, I would say Notion is more like my Scratchpad. And for like small companies, I think it'd be really, really good. I don't think we could use it at Hippo. I think at Hippo it'd be a nightmare. Yeah, I think at Hippo it'd be tough to manage it. Why don't you just use, oh yeah, okay. Yeah. No, because I like actual proper network, networking, I don't like just saying YOLO. We also need to create a VLAN. Okay, so we're going to need to create that VLAN as well. So the VLAN will get created. We're going to need to create a switch as well. Because we created a VLAN, we will then need to create a distributed port group in vSphere for our virtual machines to access the new VLAN network. Why waste your time calculating subnets when you can just always do it? Because, Fatootie, I have other networks that sit on top of other networks that go to other networks. Like, I'm not just one network, bruh. I got tons of networks. I don't like network collisions, okay? I appreciate that all of you could do 10.0.0.0.0.8 and just whatever. It's called efficiency. Okay. All right, cool. So let's see here. So we create a VLAN. What's going on though, Fitsuti? How you doing, bud? Oh. See, like what I just did there, you can do in Confluence, which is kind of a bummer. Which is like I can double click a text in Confluence and then like quote once and it'll like quote them both, like double quote it. It just deletes it in Notion. So like I said, like Notion can do pretty much everything Confluence can do, but depends on what you like more, I guess. Okay, so at that point, I think at this point we're good, right? So we create a VM. We have got a VLAN for the NFS network. We've got our distributed port group so that our VMs can access that. We can then create our volume. Yeah, okay, so let's do that. Let's start at the lowest level, which is, let's go create our network. So we're going to go here. I'm going to go to network. Look at that, chat. Look at that. Yeah, dang right. We send 12 gigabytes to Twitch. Hey, look, it's my IP address. Let's see here. Let's go to here and networks. All right, so we need to create a new network. So the last network I created was with the subnet of 4, which was for our Wi-Fi network. So NFS will be on 5. So we'll say in the USW Pro, we will call this NFS. We don't need to worry about content filtering. VLAN 6. Is that right? You say you have different networks for 192.168 for scaling. So it's yo, have you ever managed like actual infrastructure? No, I'm just kidding. I mean, dude, it's just like I'm not gonna like. Let's put it this way: if I'm provisioning 256 virtual machines per subnet, that means I'm gonna have like 30 data racks in my garage. Like at that point, man, I'm probably going to the cloud. So that's why I don't really care too much about it, because like, if I really scale out a whole subnet to that level, like I should probably move that whole thing to the cloud. Or I've got a really good reason for running it as much as I am, the way that I am. And I'm just giving you a hard time. But yeah, no, in all seriousness, that's why I don't use anything outside of 256. It's just, I want more subnets than I want more addresses. Do you recommend getting some certs in the DevOps infrastructure field, or are most of them just for show? I think most of them are just for show. I don't know anybody who does it, who looks at them for like actual, like purchase, or not purchases, sorry, and what's it called? Interviews and stuff. How does the .domains TLD work? Is it configured in your router or something? Yeah, it is. Yeah, so this right here is literally where I configure it. So this will be the nfs.alt-F4 domains, and anything on this will get a reverse lookup with the host name that it's assigned. I think NightDew, if you want to, you can definitely use certs as a way of like learning. I don't think that's bad at all. I definitely think you can definitely use it as a way of learning. But I think they're not going to help you at all in the sense of, job, whatever, competition. I don't know. We have 400 volumes on 11x. So yeah, that's another thing. Just to note, I can't even add more nodes to my cluster because of my license. So, I'm pretty capped out at the moment. And I know that's something you guys probably don't know, but yeah, I can't even add more nodes to my network right now. Okay, so VLAN ID 6, NFS, ALT-F4 domains. And that's because the license is, it's full. Okay, so this is at 86,400. I think I set this to like 300. And the reason for that is because I don't actually use DHCP anywhere. So I don't want these leases lasting very long. I think I set them to like 5 minutes, and then the lease just like, boop, goes away. These are supposed to be manually set and then stay that way. Yeah, okay. I think all of this is pretty good. So again, we're setting it up on VLAN 6, nfs.alt-f4.domains. Device isolation, we don't want to worry about. We don't need to worry about snooping or auto-scaling the network. We're going to go from 5 to 6. Now, here's the thing. Somebody said earlier about like, Maggie's, I think it was you. Yeah, you were talking about, why aren't you using 28? You could do it a bunch of different ways. Another way that you could do it if you really wanted to is you could utilize something like an auto-scaling tool, right? So this gateway has a built-in functionality that allows me to actually tell it, hey, I don't care at all about what the network's like, whatever it is. You just scale the network. Like, you take care of all of it. And then it'll, scale those out, and it'll probably just create like one, again, 8, like you said, and then just like keep going and, creating subnets as it goes. But I could use that. I could actually lean entirely on that and then just scale out across, a massive 64,000, IP address network. But again, I have more desire right now of doing things like separation of subnets and isolation of traffic and things like that than I do really worrying about scaling. So for me, it's a very simple approach. And it's one that, again, if I ever go beyond 255, I'm probably gonna have to be like, oh crap, okay, time to move. Cool. Okay, so everything else looks good here. Everything else looks good. All right, so let's add this network. Cool. So there's our network. So we've got a brand new network, NFS. It's on our USW Pro, which is on our switch. If we go to Samba here, for example, 300, yeah, that looks good. NFS 6, Samba, Wi-Fi 5. Oh, that's why. Okay, Wi-Fi is 5. Yeah, so NFS is 6. Okay, cool. All right, so there we go. So we've got our NFS network set up now. It's on 192.168.5.0/24. So we have up to 248 available IP addresses. That's good enough for me. I don't think I'm going to need 248 NFS servers. So let's go ahead and create our distributed port now. So we're going to go to distributed switch. And in this distributed switch, we're going to create a new distributed port group. We're going to call this distributed port group NFS. All right, hit next. Static binding, number of ports is fine. VLAN, we're going to put it on 6. That's what it was on, right? 6. Yep, VLAN 6. Now, it's important that I provision this network to the switch and not the router, because it's plugged into the switch and not the router. So this wouldn't necessarily work very well if I didn't have that. Static binding. VLAN 6 looks good. Finish. Okay, cool. Awesome. Okay, so now we have our NFS distributed port group. If you guys don't know what a distributed port group is, it's a abstraction in vSphere that allows you to create ports that you can connect to on any host. So, for example, if I wanted to connect to VLAN 6 on any of my network or on any of my servers, you create a distributed port because it's distributed across all those servers. And so that's what we did. And so now I've got a distributed port group that I can create VMs on that uses and accesses VLAN 6. Okay, cool. So the next thing I want to do is I want to create a folder. So we're going to create a new folder for our VM and templates, and we're going to call this NFS, like that. And now that we've got that folder, let's go automate our VM. So we're going to go to resource, and what's nice is I should have compute cluster, Kubernetes cluster, data store. Okay, so, oh, interesting. I didn't automate this. I forgot about that. Okay. Why didn't I automate this? I might not automate it then if that's the case. But let's see here. Game server, vApp, public keys. Oh, that's why I didn't automate it. Because I don't think I created public keys to use. Okay. Oh, okay. That's also why I didn't automate it, because in this scenario, it wants to provision it to any host. Okay. So yeah, so I'm actually not going to automate this. Let's go back here and we'll say this machine will need to be manually created due to the fact that we need to target a specific SPEC, a specific data. Oh, well, you know what? Hold on. Actually, this might be okay. So we tell it the data store ID. Data store. Interesting. So I might actually be able to get this data storage. This might actually be automatable. Yeah. Okay. Okay. Yeah, actually, chat, I think we can get this. Let's try it. Let's try it really quickly. So what I'm going to do is I'm going to write some automation to see if I can grab the data store. If I can grab the data store, then we can automate this. The challenge here basically being that all of my virtual machines that are automated use vSAN. vSAN being a naturally distributed storage solution. It's very easy to provision VMs on any node, but I want to provision a virtual machine on a specific node with a specific hard drive or a specific data storage, which is R610ESX02. I should be able to go into here, and just like I'm looking up this vSAN data store, I should be able to do the same thing with the R610ESX02 local. So that's what I'm going to try and do next. Okay, so let's go to data store. Let's go vSAN, copy this, and instead of this being, we'll say R610ESX02 underscore local 01, because that's the actual name of the disk. It's the first local disk on ESX02. Then we'll do the same thing here, R610 local like that. Yeah, I'm gonna have to do that. Local output get data store result like that. Okay. Cool. Okay, so then we can just say this dot local equals R610. Okay, so that should allow us to Pulumi update. It should allow us to get that now. Basically meaning this shouldn't fail. Cool, it didn't. All right. So that's good. So let's do this. Okay, so we've got our data storage. So let's go to, all right, so we're gonna resource, we're gonna copy, what is copy again? Copy here. Oh, right, okay. So we're gonna copy the game server, and we're gonna, wait, what? Paste, wait. How do I thought I could just like CP game server, and we'll call this one nfs.ts. NFS. Okay, cool. So what's kind of cool is that this templating is actually very, very similar to what I need. So for example, instead of game server args, we'll say NFS server args. We do need the cluster, we need the data store, we need the network, we need the tags, we need the template. And then create VM args, that's the same as well. We'll rename this class to be called NFS server, or we'll just call it NFS. NFS server doesn't make any sense. NFS args. Okay. So here under game server, we're going to say NFS. And then here, we're going to say NFS. Okay. So to go through our variables, data store is right, network ID is not right. We need to get our new network. So let's go add our network as well. So we're going to go here. Okay, so game server, Kubernetes, and then remember the distributed port group that we added for NFS. So we're just going to create a new one. And instead of this being game server, this will just be NFS. Boom. Right? And then NFS, output, network result. Cool. So now we have access to that network as well that we can provision to. What's Pulumi? Pulumi is automation for clouds, for your clouds. Okay, so we've got our network, distributed port group, NFS. Okay, cool. So our network ID for this is going to be NFS. There it is. We want to, our resource pool is going to be the same, rack01, and our template will still be Ubuntu. I think that's pretty good. And then the tags, args tags. Remember to change the data store. Oh, good call. Yep. So this needs to be dot, yep. Good call. Almost provisioned it directly to what I don't want to provision it to. You know, that's actually interesting. So I'm trying to avoid like just taking massive chunks out of the vSAN because it's very like performant, highly available, and we've only got like 4 terabytes of it. So like, for example, we originally had all of our assets and like Samba stuff, those 2 servers you saw before, those were on the vSAN, and they just like, they took 90% of it. They filled it up really quickly. These like back-end solutions aren't really good for us to put them on the vSAN because they take so much. But technically, because I'm only taking a terabyte and the vSAN's got like 4 terabytes available to it, I could use the vSAN right now for this NFS server and still have the high availability. The problem is that with that is that at the end of the day, I'm still going to want to rely on, you know, using each one of these drives, replicating across them, and doing it kind of really the way I'm doing it right now. So that's one thing to note is I could actually have done that, and that would have worked just because we have the space available. But I also don't want to, like, you know, completely just take over the whole server or all of the disk space in the vSAN, because one of the things that I also am considering with regards to that is just being able to scale out. Right? Like if I'm like, oh man, I need 9 more Kubernetes nodes, I want to be able to do that very easily. And I can do that right now very easily with vSAN. Like the disk space is available, everything's there. Like I'm good in that regard. So, okay. So we're going to call this volumes. So this is going to be our volumes NFS store. And I don't know if I should call it K8 volumes, right? Like, or maybe like Kubernetes volumes, but I think I might have to prefix it so that we know it's not just, you know, I guess we could just call it Kubernetes, or it could just be the Kubernetes. Oh, yeah, actually, we'll call it that. We'll just call it the Kubernetes mount. So this is for Kubernetes. Yo, Robotic Head, what's up, man? How's it going? So this is for data. Ugh. I hate allocating resources for data services because you just give it all of it and shut up. That's kind of how you have to do these things. I want to say 4, and we'll give it 8 gigs of RAM, 8192. I don't think we're going to need a ton of CPU, but I do think we're going to need the RAM for sure. At least 8 gigs across multiple nodes. That'll be good enough for a little while, I think. So the host name, that all gets set up fine. Okay, so let's talk about our disk space here. So we want 1,000, right? and we want it to go into the NFS thing. Network ID looks good. Resource pool looks good. The public keys. Oh, right. Yeah. Okay, so this needs to be updated. I need to generate public keys for NFS. So that'll need to be fixed. That looks good, though. I think this looks good, though, chat. Yeah. So it'll get a 50 gigabyte root disk. That'll be where everything goes. And then we'll give it a terabyte, what's it called? A terabyte side disk. And that's fine. That should be totally fine for now. Another thing to note, which is kind of cool, is this is completely reproducible. So when I standardized and said, okay, I want each NFS node to have, like, you know, a terabyte of disk space available to it, that means that later on, all I need to do is just copy this block, or even better off, just create more of these, and now I'm creating replicas of the exact same configuration. So yeah, it's actually very good that this is set up exactly the way it is, because this is how we're going to want to use it when we actually, you know, use something like Ceph or something else. Yo, what's up, Code Spent? Thank you for the 19 months, my dude. Yeah, man. Listen, if anything, we're here to bring that type of valuable content. Now, the one thing I am thinking about that would need to change here is the data store ID, right? Because right now, and this is something to note, data store ID, this will only provision, so we'll say only provisions to R610 ESX02, right? So that's the one thing to note about this data store is if I tried creating more virtual machines with the exact same template, yeah, they would go, but because I'm using the R610 data store, not like then the R610-01 or the 03 data store, it would just create all of them. So we would have to make it so that it does this instead. Yeah, it would have to be here, basically. Yeah. And then later on, we give each one its own data store ID, right? So this would be R6, and as a matter of fact, I guess if I wanted to even make it a little bit better, we could say R610 ESX02 data store ID, right? We could do something like that. And then I know going forward that this is just for that node. Yeah, there we go. That looks better. That looks a lot better. Yeah, so now going forward, I'll know, oh, okay, cool. You know, this is for that one thing. Or we could say data store R610 ESX02 ID. Yeah, there we go. Cool. Okay, so the only thing I need to do left is I need to generate my public key and add it to my Pulumi configuration. So how do we do that? So that's actually pretty easy. What we can do is this. We're going to do SSH keygen. And so you see this right here. This is actually one I use for the Samba services. So it looks like I did do it for Samba. You do the same thing for NFS. So I'm going to say SSH keygen, bytes 4096 TRSA home SSH NFS. I'm not going to give it a password. So I'm just going to do -n and empty quotes. And then I'm not going to give it a comment either at the end, meaning that it just won't have like any kind of tag at the end there. Okay, cool. So I'm going to run this, and then I will get generated SSH certificates. But hold on. Dang it. Friggin' hold on. I can't show it to you because it shows some stuff I don't want to show. You know what I'm saying? All right, cool. We got it. All right. So now that I've done that, my iPad died. Let's go ahead and add the secret. So to add the secret, all I have to do is .sh/, what is it? Oh yeah, nfs.pubkey. And then we pipe this and we say Pulumi C or you need something? Hang on one second, guys. All right, sorry about that. Okay, so we're going to say Pulumi config set dash dash secret because we want it to be a secret. And this will be, what did I say? Oh, crap. I forgot what this is. The virtual, and Vim NFS. What did we say it was? Oh, NFS public key. Okay, so NFS / public key. Cool. So what this is going to do is it's going to cat the output of the nfs.pub file, pipe it into the config, and set it as a secret. And there we go. NFS public key has been set. Cat NFS pub public key. And so now if I do lazy get, I should be able to go here, and don't worry, these are all secure. I'm not like doxing myself. Yeah, here you go. There you go. Look, see the public key has been added as a new secure value. Again, remember these are entirely secure. I don't have to be worried about showing you guys this stuff. Cool. Okay. So now that we've got that, I think we're ready to provision, chat. Yeah, I think we are just about good to go. Yeah. Okay. Cool. Okay, so let's go ahead and add it to the template, or add it to the configuration. So you can see here we've got like game server, Kubernetes cluster. Go here, and we're just going to copy the game server block because that's what we initially copied from, and we're going to say NFS like that, cluster data store, and the tags will all be the same. So yeah, that's basically it. It's just adding that new block of code. So import from resource NFS like that. Lazy get Pulumi update, and we should see our new VM wanting to be added. There it is. Okay. So yeah, so it wants to create the NFS scope, which is basically the container that I created for all of the NFS services. And then in there, you'll see that the name of it is Kubernetes. Now, I'm kind of nervous that I might want to prefix that. Well, I don't know. I think it's fine for now. Yeah, it's fine for now. It's fine for now. Okay, cool. All right, so let's do Pulumi update one more time. Password is Hunter2. Yeah. Okay, cool. So there you go. So I just automated the creation of our NFS virtual machine. If we click on, or if we look at it just one more time, we are creating a Kubernetes named host, or Kubernetes named virtual machine. So it's going to be actually named Kubernetes. It will be in the NFS scope. So it's going to be kubernetes.nfs.alt-f4.domains. So that'll be its actual domain. It'll have 4 cores and 8 gigs of RAM. It's going to have an Ubuntu-based operating system. It will be injected with the NFS public key that I just generated. It will have 50 gigs of primary root disk and a terabyte of secondary data disk. It'll be in the NFS folder, latest hardware version on the proper network, resource pool. Yep. Okay, that all looks good. And then our data store is the ESX02. Our network ID is on the NFS network. That's fine, and that's fine. Okay, let's do it. Pulumi update. So we're going to hit yes, and we're going to run this. Now, while we run this, we should see in a few moments the cluster start creating things. As a matter of fact, we should see recent tasks start popping up down here. Yep, there they are. So there they are. It's grabbing the focal server image from our content library. It's like a gigabyte. It's like a gigabyte in size, something like that. Looks like it just grabbed it. So it just downloaded that gigabyte file very quickly. It's now putting it onto the data storage, which is on that specific host. And as a matter of fact, you can see here's the instance being created as we speak. So here it is in the NFS folder, Kubernetes, right? This is our Kubernetes NFS service. So, okay, it's transferring files. It's deploying the OVF template. Now, remember, this whole time, we're still waiting, right? This is all part of the whole Pulumi, process, right? We're waiting for this VM to still be created. So Pulumi isn't ready to say it's done yet. It's creating the virtual machine. The deployment takes a little bit. There you go. Okay, cool. There you go. It's done. Okay, there you go. Look at this. 50 gigabytes. Hard disk, 1,000 gigabytes. And there we go. 4 CPUs, 8 gigs of RAM, 50, 1,000. Connected, disconnected. Yep, all that good stuff. So we're just waiting for the VM to finish booting, which should be in a few moments. Is this some infrastructure as code type shit? Yes, it is. As a matter of fact. Yep. I run it IAC against my own data center at home. We don't we don't do really anything manually. We don't have to do here. There we go. So the VM is booted. I should see an IP address in the next. Yep, there it is. 192.168.5.6. So, and then there you go, chat. Look at that. Pulumi has successfully said that it has been created and deployed. So now I should be able to do SSH-I NFS, right? Ubuntu at 192.168.5. What was it? 6? Yeah, 6. Do you think it'll work? Do you think it'll work, chat? If I hit enter, do you think it'll work? Here you go, chat. Let's do a quick prediction. Do you think after all of the stuff that I just did, will it work first try? You got 60 seconds. Do you think after all, think about that. Everything I just did, I spent all of the time writing the documentation, thinking about how it would all get set up, making sure that the network would be set up properly, making sure that the VM would be set up properly. Do you think that I set it up right? Do you think that if I hit enter, I'll actually be able to SSH into this node? This is that moment, right? Where you just created your first virtual machine and you're like, can I connect to it? Do you think I can do that, chat? Do you think I've standardized my infrastructure well enough to where I can create VMs on the fly and connect to them? I created a whole virtual LAN, dude. I created a whole virtual LAN, whole new virtual network, assigned the VM to that network, right? Provisioned the VM on that network, templated the VM, automated it, all in our data center. How dare you doubt me? How dare you doubt me? Of course it'll work. I know what I'm doing, chat. How dare you doubt me? How dare you doubt me? Of course it was gonna work. Your boy knows what he's doing. Everyone who just doubted me, I'm sorry. I'm sorry to say. Yeah, no, it worked. It worked. First time. I mean, again, chat, like when we talk about earlier, when I was telling you guys how I wanted to set up our data center, how I wanted to manage my data center, I wanted to do it exactly like I do it at work. Same infrastructure as code, same types of, automation, same types of like designs and principles, and create a new network, isolate, like all of that kind of stuff we can do here. All of that stuff we can do here. Here's a kicker, chat. Do you think my VM is on the internet? Do you think I can actually access the internet with it? And yes, I can. Of course I can. So it was, I appreciate it. No internet. Yeah, internet is fake. Will it work first try? Yes, it did. Congratulations on all you people who got points. All right, so there we go. So let's do this really quickly before I do this app fdisk-l. Yeah, so we got 1,000 gigabytes right here. Virtual disk. Yeah. Yeah, that'll do it. 50 gigs. Okay. Wait. What is it doing? It's not. Is it redoing a prediction? Is it rerunning a prediction right now? Oh, no, go to. Okay, I see. Just the result. Okay, I was super confused. I was like, what? Okay, so while this is doing this, we're going to go ahead and just manually set up this. So we're going to say NFS Ubuntu. We're just going to manually set up the NFS stuff. Okay. So you install it, start the service. You can configure the directories to export by adding the exports, for example. Make any custom out points you're adding to created serve, scratch, config. You can replace star with one of the host name formats. There are a number of options for setting. So, hey, does anyone out here have like the optimal NFS configuration by any chance? I have no idea. I don't remember how to configure NFS in the way that, like, it's actually performant and stuff. You guys have, does anyone out there have like an NFS configuration that they they like? I got you. I just did. Oh, hell yeah. Thank you, Fatudi. I appreciate you so much. There's another thing we need to do as well that we forgot. We will also need to set up a new domain in Azure for the TLD kubernetes.nfs.alt-f4.domains. Yeah. Edit it and nice. Appreciate you, Fatudi. Hell yeah. You can go yourself. Should ban you for that one. I really should. I should just be like, you know what? You're gonna sit on ice for a moment. Thank you, man. I'm glad you appreciate it. Okay, so this is pretty easy though. Okay. So let's do this. Did I reboot you? Have I rebooted this machine yet? It looks like I did. Did I? I did. Okay, cool. Okay, fdisk-l, fdisk, dev, SDB. Have you ever partitioned a hard drive before, chat? If you haven't, you're about to see how you do it. You select the hard drive, use something like fdisk, and then you go N, P1, enter, P, W, and you're done. and that's how you use fdisk. So then we want to mkfs ext4 dev sdb1, pretty much. And now we're going to format that new partition to ext4. Now, don't come at me with, why aren't you using this or that or XFS or blah, blah, blah or ButterFS or whatever. I don't care. Okay? I don't care. Just shut up. Let me make my stupid thing. fstab. Okay, so let's do this. Make dir mount data. This is going to be the, why aren't you using CFS, bro? Thanks, man. The other one that I couldn't think of. All right, so let's make a mount path. So it's going to be mount data. That's where all the data is going to go. No. And we're going to add that to our fstab. So we're going to do dev sdb1 / mount data ext4. Oh, look at that. They use vfat for the boot. That's interesting. Defaults 0 1. Is it fstab additional hard drive? Is it 0 0? Okay, we'll do 0 0. Can never remember if it's 0 0. We'll reboot. That might not have been a good idea. I hope that works. I didn't check the I didn't check the fstab before I saved it. Oh boy. Probably shouldn't have done that. I think we're okay. I think you're still rebooting. Yeah, okay. Yeah, by the way, don't just like save your fstab and not know what you're doing. Oh, crap. Did I just bork this machine? Oh, no, I didn't. Okay, cool. Woo, that was scary. All right, we're good. Fstat fdisk-l sdb sda cd mount lost and found. Okay, cool. Yeah, it looks like it's good because we're getting the old lost and found. All right, so we've got our additional hard drive. We've got our VM set up. Now we can install kernel server. Kubernetes. Yes. It's sentient. Okay, so then we will start the service. Cool. You can configure the directories to be exported by adding them to the etc exports file. For example, serve row sync tree scratch serve read write read only. Okay, so this would be read write scratch read write async no sub. Okay, so yeah, I think this is the one that we want. Vim etc exports. Perfect. And this is going to be under any host name, Kubernetes, read write, async, no subtree, no root squash, no exec. Scratch data. All right, let's do this. Can I? So this is at the mount path data, but I need this to go to. Maybe we do put it in serve data instead of mount data. Yeah, I think that's what we're gonna do. Yeah, make dir serve data, vim etc fstab serve data. Yeah, and reboot. Careful with that star. I'm good. I got it. I'm fine. Okay. And I haven't touched VMs like this in a while. I normally automate these things. Control panel. Okay, cool. So the only thing that does kind of like concern me a little bit is these VM names are unique. So technically, like arc, assets, worker, blah, 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 all that stuff, they're all possibly collidable. And I just like named this one Kubernetes. So I don't think it's going to be something I keep as well. I'll probably have a better naming convention like NFS01 or NFS02 or something like that. But that'll be when we cluster it. Right now, I'm not super worried about it. Okay. That's not what I wanted to do. Okay, so if we do fstab, serve data, mount data. Okay, so rm-rf data, cd serve, ls-alh data. If we go in here, cool. Okay, so that looks good. Vim etc fstab. Oh, not fstab, sorry, exports. Serve data, Kubernetes, read write. Okay, so yeah, this should be good. Let's do this as well. Let's go to, we need to make our Terraform update, so let's do that too. So print working directory, quirk, nope. We need to go to ALT-F4, and we need to say DNS a record, and where it says plex nas ALT-F4 domains console. Do I not have a DNS zone for Dren TV? Okay, we'll just create this manually too then. I think I did all this manually because I wasn't going to keep any of this. Let's go to Azure really quickly. DNS zones. We're going to go to ALT-F4 domains. We're going to create a new child zone. ALT-F4 domain, ALT-F4 domains, and this will be nfs.alt-f4 domains. Perfect. View and create. Okay, so alt-f4.-domain, nfs.alt-f4 domains, alt-f4 domains, perfect. DNS zones should be made. Make my zone. Where are all these Kubernetes domains? Oh, right. Never mind. Come on. I want my NFS zone. Give me. There it is. There we go. Cool. All right. So now that we've got this, we're going to create a new record set. And we're going to call this record set Kubernetes. A record. It'll be set for 5 minutes. And the address is this guy right here. 192.168.56. 5 minutes. Kubernetes.nfs.alt-f4 domains. Perfect. All right, so now I should be able to dig Kubernetes, or actually ping oh my gosh, netes.nfs.alt-f4.domains. Hey, look at that. It works. Okay, cool. All right, so I can route to it. It's got its thing set up, I guess. It should be... Wait, unknown keyword, no exec. Oh. What? It's just different, you know? It's just different. I'm guessing no exec is like a new thing or something. So read write, async, no subtree check, no root squash. Let's just get rid of the no exec. I'm pretty confident I want no root squash. Well, maybe I do. Read write async. Sync. FS async versus sync. By default, the root user is squashed to the user nobody so that the NFS access is compartmentalized. This point is important because if a rogue user boots the system from some, the user can be a root on the system and change IP. Yeah, okay. So we'll get rid of no root squash. We'll keep subtree check, no subtree check. Where is, no, synchronous, okay. So most people use synchronous option on their server. For synchronous writes, the server replies to the NFS client only when the data was turned into stable storage. Many people prefer this option because they have little chance of losing data if the NFS server is connected to its loss. Asynchronous mode allows the server to rely on NFS client as soon as it processes the IO request and sent to the local file system. That is, it does not wait for the data written to stable storage before responding to the NFS client. This can save time for IO requests and improve performance. However, if the NFS server crashes before the IO request gets to the disk, you could lose data. Synchronous or asynchronous mode can be set when the file system is mounted on the client, simply putting we'll try sync for now. We'll see what the performance is like on synchronous. I'm curious. I am curious. All right, there we go. So now I should have NFS available to me. NFS, apparently don't have it here. Okay. So now that I have that, now we can kind of loop back to what we were originally working on, which is we need to connect our discourse to that. So I guess the next thing will be is Kubernetes NFS. How do we use NFS with Kubernetes? And this is following using existing network file system share mounted, unlike pod, unlike empty-dir, which is erased, pod removed, are preserved the volume merely unmounted. This means NFS could be popular data. Da, da, da. Okay, yeah, so let's look at NFS examples. I just want to see an example. NFS PV YAML. Here we go. Okay. So, okay, perfect. So this is what we're looking for. So we basically want to change the stuff in our automation, right, to NFS. So remember, the whole reason why we're doing this is because I am releasing our new wiki, the ALT-F4 wiki. This wiki will have basically all of the documentation that I write on stream, as well as documentation for videos and things like that that I feel that I want to add. Not only will it be something that I'm going to be adding tons of my own documentation to, it will also be something that you guys can add to as well, and even comment on and things like that if you'd like. And so earlier when I actually released it for the first time, the server crashed. And that just was because we didn't have enough replicas. And so for us to be able to do what we want to do, I'm basically scaling it out, and that's why we ran into what we ran into. Now remember, on this stream, it's very real world here. Whenever we find ourselves in a problem that we need to solve something, we do. And so that's where this new article, that if you guys are curious on how you could do discourse distributed deployments, I will be adding this to the wiki once it's up, so that you guys can see how I set it up on my end and potentially set it up on your end as well. So yeah, so getting back to where we were with the discourse part, now that we have an NFS service available to us, what we really want to do is we want to change how the persistence works so that we use NFS essentially. The same. Also for random bugs, do a little support with Terraform. Yeah, I mean, I don't know. I personally didn't mind it too much, but I didn't use it massively. So, I don't know. I like Pulumi. I'm very happy with Pulumi. I don't really need to use the user interface too much. Okay, so let's do this. I need to keep this as a reference. Here we go. So setting up replication. Okay. So password, PostgreSQL, discourse, skip install. So we don't want to skip the install. Storage class NFS. You need to if you don't have provisioner of the sort, we recommend that you install the NFS provisioner chart with the correct parameters such as persistence enabled and map it to a read write only. What is the NFS provisioner chart? Is that like something else I need to? NFS server provisioner. Oh, this is just exactly what. Never mind. This isn't what I want. Persistence, standard, default class, the following recommended, standard. Yeah, that's not what I want. Okay, so to get this, persistent volume, access mode, mount options. So we need to get access to the spec of the persistent volume spec. Is there a way that we can actually give persistent storage class NFS, persistent storage class NFS? No, there's got to be another way that we can do that. Persistence enable true and persistence size 10 gig and map it to a 10. Okay. So where is persistence? Database, ingress, volume permissions, sidekick. Here we go, persistence. So persistence storage class, existing claim, access mode size selector. This is it? Persistence dot. Okay, so it looks like there's one other thing we might need to do. They're wanting us to use, and I actually don't know if there is something we need to do because I've never done this before, but from my Kubernetes knowledge, I feel like, I don't know, it might work. What they're telling us here is they're saying that they want us to use the storage class NFS and the persistent storage class NFS. But the way that this works is this is a persistent volume itself. What it's suggesting is that it wants us to set up like something like this. Well, this is a persistent volume claim, but basically a storage class that is NFS that then allows me to provide NFS classes to my services. Right, because I don't have an NFS storage class. Like if we go back here, K9's storage class, I've only got the one, vSAN. So if I try using NFS as a storage class, it's not going to work. NFS storage class. How do you use NFS in a Kubernetes cluster? I'm nervous that it might want me to actually give it an existing volume claim. That might be what we need to do here. That might be the better play, because there's another option in here that says instead of doing any of this, what I could do, Edward, calm down, buddy. What I could do is create existing volume claims and put it on that. And the thing that's interesting that we haven't even really talked about is that this is going to want to put all of the stuff on NFS, right? The Postgres, the Redis, and the Discourse instance itself. But I could just set up a volume claim for just one node, which is the Discourse service itself, and then call it a day. I just don't know how they did like storage class NFS like this. Like if I could create I would love to create a storage class for my thing. I just don't know exactly how you do that. NFS. Oh, well, maybe. Oh, okay. Boom. All right. Never mind. I figured it out. Okay, we're good. Never mind. Okay, so I need to create a storage class though, but this is for Valero tunnel vault. So we definitely could just use this right here. This would allow us to create a storage class for our NFS server, right? Provisioner, example.com, external NFS. Do you need this provisioner thing? Kubernetes isn't clear, but you need an external provisioner to create a storage class for NFS. Here are some examples. Oh. Okay. Oh, geez. Oh, Kubernetes, why you got to do this to me? Why you always got to like add 9 steps just to do one thing? That's why they're okay. So that's what they mean by the NFS provisioner chart. Bitnami, do they have one? Does Bitnami have a what? No longer be updated. It's an out of tree dynamic provisioner. Can you quickly use a deploy store fast? Oh, well, this looks like this might be something we're looking for. NFS provisioner. But is this the as of 13? It will no longer be updated for from. Yeah, I know it does. Yeah. Charge deprecated no longer be supported. Cool. There's got to be a chart somewhere for this thing. Here we go. How old is this? 2 years ago. Yeah, they're saying that this is out of date now. Yo, what's up, Owen? How's it going? So I could use this. I could use this stable NFS server provisioner. Persistent size. Has now been installed. Persistent and has now been created and is available for version volume. You can use this storage class for volume claim with the correct storage name attribute. Doing good. Trying to figure out how I want to do this. Read write many. Yeah, see the read write many? Okay. Yeah, I think I know what we want to do. Oops, I'm gonna do that. Okay, so here's what I want to do. We're going to have to get an NFS provisioner added to the cluster, which is a bit unfortunate, but it is what it is. We can add it here in this automation that we've got right here, but we need to add it really just anywhere. Like, see where Samba is right here? Like, it could be anywhere, but we need to add. What's interesting is that they're saying that this is deprecated and no Bootstrap's provisioner deployment. What I don't understand is like, how is this deprecated? Yeah, archive, now read only. Move to, oh, okay, here we go. So, okay, maybe the Ganesha thing is like the, oh, I guess that is just the option now. Okay. NFS Ganesha server and external provisioner is an out-of-tree dynamic provisioner for Kubernetes. You can use it to quickly, easily shared storage that works almost anywhere. Can write your own tree out of dynamic provisioner. Detail below. It works. Storage class object can be specify an instance of the provisioner in tree. Okay. Then instance of NS will be watch person and ask storage automatically. The repository was migrated from. Some of the following instructions will be updated. The test container, make build quick start. Okay. Choose some volume for your external instance to store and its state and a data volume mount at export. Deploy Kubernetes deployment.yaml. Okay. This is a deployment. Oh yeah. Okay. So service account, service, deployment, provisioner, example.com/nfs. Choose a provisioner name for a storage class and deploy it. Provisioner example and set. Okay, I see. And set it in deploy Kubernetes deployment and then deploy that. Okay. Create a cluster role, cluster binding, and role binding. This is necessary. Create cluster role RBAC. Oh, we're going to have to. We have to automate some stuff. Hey, Rebitnami, do you use their charts? I struggle to find example charts or docs for their chart values. Seems like the only documentation is their code. Yes, that's 100% true. Yeah. Yeah. There's not much I can say about that one. Except for yes, you are right. Yeah. That's pretty much what I do live coding. To be honest with you. I wish I could help you more, but yeah, no, I pretty much do the exact same thing. Choose a volume, mount path. Volume mounts mount path. Oh, this isn't right, though. I don't want... I already have... I don't... Oh, is this just for the export? Wait, choose a volume instance and store data that export. Doesn't... Wait, I'm super confused on what this is. Can I just create the class? I think service deployment. I just need the class, dude. Like, I'm pretty sure I just need the class. Deploy Kubernetes class. Storage class. Provisioner example NFS. So this doesn't do exactly what I want it to do. Kubernetes NFS storage class. Oh yeah, no, for sure. I totally agree with you on that one. So yeah, this is same storage as a PVC. So Orca, I'm a little lost, honestly. Well, no, I mean I'm not. I'm entirely. I know where I'm supposed to be, but so yeah, the challenge here is, and this is kind of like literally going over exactly what live coding is talking about. The configuration available to this chart is to basically either give it existing claims across the board, like just create a bunch of claims and give those claims to it, right? Or use something like the storage class. It doesn't really give me the option of like much else, which kind of makes sense, right? It's really supposed to just hook to a storage class and do what it's supposed to. But it wants me to use an NFS storage class, which is telling me that they want me to install the NFS provisioner chart and then do it that way. But like, I don't want to provision NFS servers, right? I just want a storage class that I can use with my NFS server that exists somewhere else. And I don't know how to create a storage class for that. Like, I want a storage class that is my server information, right? So I understand that you're saying you don't, but I need more information than just you don't. That is gonna just set the storage class name to whatever you want other than an existing storage class. Okay, that's great, but then where else do I provide the information for the like NFS stuff? Because all I've got here is enabled storage class, existing claim, access mode, size, and selector. Like, that's it. That's all I've got in this chart. You feel me? In the PV. What? So I think what is going to happen is I'm going to have to create volume claims outside of it and give these claims to, what's it called? I think that's what I'm going to have to do. I think that's how this will work, is then I don't have to worry about creating a class. I just create volume claims and then tell it, say, hey, use, that's what I'm going to do. That's what I'm going to do. Existing claim. Yeah, but that's not what you said. That's not what you said. So I'm gonna do it the way I said it. Just kidding. Exactly what I said. I don't think that is at all what you said, sir. As a matter of fact, I think you're lying. All right, so let's do existing claim. So this is for manually before bound. Okay. Wait, what? No, I don't think so. I don't think so at all. Yo, David, thank you for the follow. Appreciate you. Patootie, thank you for the resub as well, my dude. Sorry if I missed that. Do you know what I'm kind of interested in, though? Is... Where'd you go? Let's go back here. Well, actually here. Well, I'll just go here. Existing claim, right? That's only available in one place. Persistence.existing claim. So like, for example, if we go back here and then we go to discourse like such, then persistence, there we go. We're going to get rid of this. We don't need this. Oops. We need that though. And then this will be existing claim. And then we'll call this, I don't know, whatever. For now, we'll just make that blank. So that is fine. But then what about the claims for like the database and stuff? Yeah, because see, you could do PostgreSQL persistence existing claim as well. Yeah, Orca, I swear, God, I'm gonna do the same thing to you that I always say to a Toda. I'm gonna throw my mouse at you. I love it. I always say that later on. It's like, oh, well, okay, never mind. That's what they were saying. I know what it says. Postgres. So these must be the provider. So does that mean? I guess the question is could I have the vSAN be the persistence providers for the database, right? And then have NFS just for the data of discourse. I would much rather do that. I think we're going to do that. I'm just giving you a hard time, by the way, Orca. Okay, so let's do this then. Before we discourse email, before we do all of that, let's create a new volume claim. So we're going to say const volume or PVC equals new physical volume claim. Is that not like a thing? Oh, geez. Kubernetes. Oh, it's going to be under core. Never mind. So core.v1.persistent volume claim. And we'll call this, we could just call it labels.app. Sure. Postgres chart is a dependency and deploy with those. You can look at the, yeah. No, I got you. The whole inheritance thing. Okay, cool. Okay, so name args options. So persistent volume claim, we're going to do metadata, of course. Namespace, and this will be in namespace metadata name. Name will be labels.app. So this will be a discourse persistent volume claim. It'll be in that. Okay, so now, where's the NFS stuff? Okay, here we go. So, spec. Oh, wait, can I do it as a claim, though? Persistent volume claim. Okay, here we go. Wait, what? Where's the NFS stuff for the... Oh, my gosh. You have to create a PV first and then give it a claim? Okay. All right, that's fine. Const PV. I got you. I got you, Orca. I was just giving you a hard time, buddy. V1 persistent volume labels.app. My brain just wants to do this thing where it's like, okay, it's going to either be the way that I predict, which is a bunch of steps that I have to take, or it's going to be something that I don't have to do and I get really lucky. Normally it's, the latter. Or no, the first one, which is I have to do a bunch of stuff. I was hoping I was going to get lucky, and I wasn't. Nice helmet. What are you talking about? Okay, so spec PV spec storage class name. Can I just call it like whatever I want? You said I can call it whatever I want. Like if I wanted to call it NFS, I could, right? Capacity. Okay, so I need to figure out what the capacity of this is going to be. Can I just do, I can just like like, yeah, okay. What is the size they set theirs to? I don't even know like what this is set to. Yeah, no, I'm kind of curious on what they set their volume storage size to. Wait, what? Helpers. Discourse, database, host, database name, secret, name, host, Redis port, Redis name. Oh, come on, dude. Where? I actually really hate Helm charts. They're so confusing. It's 100 gigs. Oh no, it's 10 gigs. That's 10 gigs. Okay. Put 100. Freaked me out, dude. 10 gigs. Is it? Can I just do that? GI like that? You can. It doesn't matter. I want to. Okay. I know it doesn't matter. I realize it's just gonna exist on a file system and take up all the terabyte if it wants to. Just let me believe. Okay. I understand that this is all just reference nonsense. Let me believe. All right. Okay. So access modes. Access modes. Is this an? It is an array. Okay. And then we'll say for access modes, this needs to be read, write, many. That's what we want. Yeah, read, write, many. And so now we're going to go down to NFS. Look at that, NFS. So excited. NFS, like this. And then path. So our path is, what did we say? Serve/data. Right? And then our server should be kubernetes.alt or .nfs.alt-F4.domains. Read, write, many. Okay, so what are you having a problem with? Yeah, that's the path in the argument of type. Wait, what are you having a problem with? Oh wait, how do I? Crap, I don't remember how to trigger my code actions. Storage class name, spec, access modes, capacity, storage. Oh, I didn't do storage right. Okay. Storage. 10. Yeah. There we go. There we go. Okay, so here's a question. And this is something I'm actually kind of curious for anyone out there. If I create a volume, right, in serve, like in the path is serve data, right? Is it going to create a folder on my end? Like, is it going to, you see what I'm saying? Like, or do I have to give it like the direct path? Like, is this volume actually supposed to be like /discourse? You see what I'm saying? Like, cause this is something I wanted, like this specific, you can use some path in the container. You can use subpath in the container. Yeah, but I don't know if I can, like, I can't, you know what I mean? Like, I don't know if I can change that with this deployment. That's, you know what I'm saying? Like, that's kind of the problem is I need to be able to isolate and scope it. So I'm wondering, like, could I, because this is just a persistent volume. Could I just tell it, hey, I wanted to create a persistent volume here. Like, how would I make sure that, because again, if I want to use other services with NFS, I want to make sure that I can just follow the same pattern. You know what I mean? So what I'm saying is, okay, so I don't know if that's just, I don't know if that what you're saying is translating to what I'm asking. Right, but can I modify the subpath? Subpath is a postfix to the server path, and mount path is where the mouse is. Yeah, I'm just wondering if I can actually modify that. Like again, remember, I only have like persistent, storage class, existing, volume, claim, and selector. I don't know if I can change that in this Helm chart. So that's why I'm wondering if I should just do it like this. But I don't know. Like, I wonder if it makes more sense. You know what? I wonder if it makes more sense for me to go to the Samba server. You can always post render the template. Yeah, no, I think what I'm going to do instead is I'm going to go here and I'm going to do mount. Yeah, exactly. I don't want to touch it. I think what I'm going to do instead is I'm going to go to serve and then data. And here I'm going to make mounts for stuff, and it'll just be manual, right? So then we'll do vim exports, right? And so where this is data, we'll say data discourse, right? And so now this is a mount path just for discourse. Yeah, I think that's the play. Yeah, I think that's the play, because then I know how to manage it, right? Like it's just easier that way. Is it P? How do you show? I forget how you show all of your like active exports, but exports A. Okay. Yeah, cool. So that should work. So now it should be data discourse. Perfect. I don't think subpath would have made the pass for you, but exporting serve data would export all the child directories as well. So I know that it would export all the child directories, but can it mount? Like if I mount, for example, I probably should have just fucking tried it. Sorry, I should have just it. You can also, okay. Really? So if we do this, right, which is really what I want, right? And then I come over here and we just set the path to this. This is a lot. Oh, you're saying done this a lot. Okay, so we can, okay, cool. All right, cool. Perfect. Okay, so in that case then, chat, I think we are good. Now, I guess here's another question. Do I have to create that directory before, or will it even do that? Like, I probably have to at least come in here and create the directory, right? Like, I would imagine it won't create that directory for me. It needs to exist. Okay. That's what I thought. Yo, Mr. Emax, what's up, man? How's it going? Okay, cool. All right, so we've got that. This is actually really good because I needed a way of standardizing how to like mount NFS points in the infrastructure. Knowing that this is at least the Kubernetes approach to it is going to be really easy. Okay, so I think that's all we need for our volume. Get rid of that. Let's do Kubernetes NFS. Okay. Use a lot of oh, really? Interesting. That is interesting. Okay, here we go. So persistent volume claim, NFS example. Quick start. Yeah, see, they want us to like, they want me to like, look at this. NFS server. Like you create all the NFS servers and then then you do the PV and PC. Like they want to, I don't know. It's kind of interesting how they like say throw the NFS thing in there first. Okay, so the only thing we really need to do is add the mount options. 8. Mount options. Also, by the way, chat, all of this is available in the VOD and as well as the wiki once I'm done. That's why, trust me, chat, I got cool shit for you guys. I got cool stuff for you guys. I'm excited. Okay, cool. NFS version 4.2. Okay, that looks good. So we got mount options, persistent volume, 10 gigs, discourse, NFS. Okay, yeah, all of this looks good. Okay, cool. So that's our volume. Now let's do our volume claim, PVC. So our volume claim is going to be spec, right? And then in the spec, we're going to say access modes, read, write many, just like over there. Storage class name. This can also just be like that, right? Or NFS, I guess. NFS. Resources. Oh, interesting. Requests 1 month. Oh, I don't need any of that, do I? I could just do volume name, right? Volume name pv dot metadata dot name. That's all I need, right? I don't even think I need this. And then down here at the bottom, we say existing claim pv.metadata.name. There we go. We have now we've now gone full circle and back to where we originally started of trying to deploy this thing. Okay, cool. So for anyone just catching up, hey, appreciate you being here. Earlier on in the stream, I started working on what I'm going to be doing now more often, which are stream notes. And these stream notes are talking a bit about the computer, or I'm sorry, are talking a bit about what I do on the stream and like kind of how we go through the stream, as well as my notes and stuff like that. When I did that, I also talked about deploying our new discourse wiki. And when I did that, we crashed it. And so we needed to scale out at that point before I could go any further so that you guys could join it as well. And so through that, we discovered that we needed NFS in our Kubernetes cluster so that we could provision services to NFS. So we created an NFS server. We did all of that. I created documentation on all of that and how we did it. And all of this is going to be in that new wiki. So that's kind of the point is like there's so much stuff that we do here that I just feel like if we just start documenting it all, we're going to get a lot of really cool things. So that's kind of the goal. Okay, cool. And so we now have what looks like an NFS server with a discourse folder in it that we can mount. And we're going to create a persistent volume that uses NFS to connect to our Kubernetes service, our Kubernetes NFS service, mount our discourse path, and then create a claim for it and pass that claim off to the discourse service itself. So I think we're pretty much good to go. PVC, PV. Is NFS utils installed on the nodes already? Yeah, I would assume so. I don't know. I can look at one of them. System 0. Oh wait, SSH-I. Kubernetes. I don't know what this node is, but we'll see. System 01. There we go. NFS. Oh geez, that did something. Where is NFS client? Where NFS client? NFS client help. Command not found. Wait, does that mean that it doesn't actually have NFS installed? Apt install NFS common? Oh, it doesn't. That's what I would need, right? NFS common. Oh, NFS utils or NFS utils. Is it NFS utils? No, yeah, it's NFS common. Yeah. Okay, so there is something else we can do here. Hold on. There is an Ansible repository, development repository, GitHub. Ooh, it's not on this computer though, is it? Yeah, it's not in this VM. All right, we gotta go to an older VM. So I could do this two ways. I could just SSH into each node and install SSH onto it, but I don't want to do that, or NFS comment onto that, and I don't want to do that. I do have Ansible automation. I just can't show it all to you guys. And the reason for that is because it's got secrets in it that I can't show. But I can update the automation and run that. I think. Oh, dude, that might actually require me to do a bit of work. Yes. Ansible. Virtual on-prem Ansible. Yeah, so this repository right here is an Ansible playbook that I am still working on. And if I do like git status, you'll see that like, yeah, I've got a bunch of stuff in here. One of the things that are in here is the key that's used to like join clusters and stuff like that. I don't think I actually need it, but I don't think I need it. Ansible playbook inventory values extra vars values main.yaml. Do I have a values in here? I don't. So Ansible playbook inventory extra vars values. So I don't think this is the playbook that I ran. Yeah. Yeah, I don't want to show you guys this stuff. That's the problem. I don't want to show you guys this stuff. All right, let me do this. I haven't taken another break yet. I'm going to take another break here. We're going to wrap all this stuff up. We're going to get this thing deployed, and then I'm probably going to call it. So we still probably got like at least another hour or so in the stream. But yeah, let me go ahead and do this. Let me go ahead and take a quick break, stretch my legs. I think what's going to happen is I'm going to run this playbook, and we'll see what happens. But yeah, from what I know, like let's look at the inventory really quickly. Should be able to look at that. Yeah, there you go. So yeah, you can see here the system nodes, the worker nodes, all of that stuff is in there. So I should be able to run this playbook and update it. As a matter of fact, I should be able to do this. Yeah. What we're looking for is install tasks. So Kubernetes install system tasks. Yeah, here it is right here. So this system, see this right here? Upgrade packages, Python pip. We need to say right here, LMNO, NFS common. Yeah. Except for we're not going to do that. Yeah, we're not going to do that. Because I don't want to deal with, like, massive upgrading everything right now. I don't think that would be a good idea. Yeah, that looks good. Okay. So yeah, we should be able to run this. So let me take a quick break. When I come back, I'm going to run this playbook. It'll add the NFS common to all of the hosts, which will then make it so that we can go back to our other automation and deploy this discourse service. So yeah, all right, give me a moment. I'm going to run a quick ad while I do so. I just want to say thank you guys so much for hanging out with me today. If you are new to our wonderful community, be sure to check out our fantastic Discord as well as our social medias. One other thing to note, we do have a brand new YouTube video out. We did a partnership with Azure, Microsoft Azure, a while ago, and they are finally releasing the series of the migration to Azure series that we did with them. If you guys are curious about that, you can check that out right there. That is the first of the series, so you guys can at least watch me while I'm not here. And then when I get back, we will continue. So yeah, thank you guys. Give me a brief moment. I'll be right back. I'm running an ad as well. Be right back. 1 second. All right, chat. Let's knock this out. All right. I'm back. Okay. Let's get this thing deployed. Okay. So the first thing I want to do is I actually want to, okay, go here, Ansible. So I should be able to do Ansible playbook, inventory. Yep. Okay. So we're not going to do extra vars because I don't think I need anything. But we are going to do main.yaml. Is it dry run? Isn't that what it is? Dash dry run. Chat. Yo, thank you for the follow, man. Appreciate you. I guess I could just do help. There we go. Become, flush, forks, skip tags. Where's the dry run thing? Inventory, diff, check. Oh, it's just dash check. Okay, cool. Dash check. Okay. All right, so hold on. I don't know what this is going to do because like I told you before, this has got a lot of stuff on it. So I want to just make sure I'm not going to show anything and like dock the whole, this is the whole Kubernetes cluster, guys. So I got to be a little careful. Okay, perfect. All right, we're good. Check it out. We're good. All right, so I can literally just run this one part and we'll be good. So that's what we're going to do. So I'm going to run this. Right? So it's going to install all of the other packages, make sure they're up to date. There we go. There we go. There we go. Do we get everything? Hold on. Got a few more installing. I love automation, chat. It's the best. Yo, what's up, Monty? How's it going? Loving the stream. Do you have any tips on making a coding stream entertaining? Yeah, be yourself. Like through and through. I didn't know I was going to be like the DevOps guy. I didn't, to be honest with you. That was just something I kind of fell into because I loved DevOps. It's you know, there's so many people out there like who are themselves and they can go really far with that, or they're themselves and it becomes challenging. I understand both because I deal with both. Sometimes it's really easy, sometimes it's not, you know. I think the biggest point is just being yourself as much as you humanly possibly can be. Yeah. Oh, that's PVC. Whoops. Yeah, so Monty, you know, and for anyone else out there interested in streaming or just being a content creator in this sphere, this like ecosystem, I think it's really important to find your own voice and, you know, learn how to communicate with that voice really, really well. You know, learn how to be comfortable with that voice as well, you know, also, because there are times where you're going to be right and there's going to be times where you're going to be wrong. Get ready for both. Okay, cool. So we've crashed our discourse service. We have since learned that to replicate our discourse service, we have to create physical volumes in Kubernetes that can actually handle multi-writes. We didn't have a physical volume provider that could do that. So we had to do a little bit of investigation and a little bit of deep dive into how to do a discourse distributed deployment within our environment, right? I wrote down this technical document that I'm going to be sharing with all of you guys at the end of the stream, as long as the VOD and everything else. Yeah, no worries, Monty, no worries. But we got to a proposed solution where we were able to set up a NFS server with a terabyte of disk space, create a NFS configuration in that for Kubernetes, provision that on a NFS network, right? Have all of the standardizations and everything that we're used to, but for this new service. So now we're at to the point where the Kubernetes nodes have NFS common installed on them, and we should be good to actually try and create this volume and persist it over NFS. So let's give it a shot, chat. Let's see if we can do it. So I'm going to do update like this. And yeah, of course. No worries at all. Now what's interesting is the database did not get deleted, right? Only, so here's, okay, so Orca, I don't know if you're out there, or for anyone else who's been sticking around this whole time, I'm wondering if it really matters that we lost the data directory for Discourse, because if you think about it, the Postgres database is on the vSAN shared storage, which is highly available and should never go down, right? The Redis is also on vSAN, which is highly available and should never go down, right? So those are the important things. So what exactly, if it's not the database and the caching, what exactly did we just delete and, are about to back up? That's kind of the question. And I'm thinking we might actually want to skip. We still might want to skip before we do this, I think we might want to skip the install. Do not run the Discourse installation wizard. I think we might want to. Yeah, let's do that really quickly as well. Oh, hey, Monsi, are you there? I got one more piece of advice for you. And this is hands down the biggest piece of advice I can give you. Oh, it is there. Exactly, Palmbase. Yeah, exactly. Okay, so I did have it, so I think we're good. Yeah. So yeah, for anyone else interested in doing like content creation in general, do it because you love it. A lot of people do it, I'm sure, because they, want to make money and stuff, which is fair. Like all of us do, duh. But you're going to have good days and you're going to have bad days and you're going to have worse days and you're going to have fantastic days. It's just, it's so unpredictable of a market to get to a level where you have predictability is like millions and millions of dollars. It's crazy. And so, yeah, I think it's really important to be completely realistic with yourself and comfortable with like not having great days or having great days. And, don't get too excited. Like there's always something new on the horizon for you. The best thing you can do is just take the little wins, keep moving and have fun, Okay, so look at this. So we're going to replace our stateful set, and then replace our volume claim. Then we get a new volume claim and persistent volume. All right, let's see what this does. I'm kind of interested. Not kind of, I am super interested. So let's do this. Let's go to PV first. So we should see a new physical volume appear in this list. Dude, I love K9s. It's the best. That's how I run my high availability, just external Postgres. Oh, yeah. I got you. Look at all that RWO. You see marked available. Oh, there we go. NFS. 8. There we go. Required value. Persistent volume claim in Discourse. PVC. Okay. Discourse. What was it? Spec resources storage. Spec resources storage. What? Okay. So what goes in here though? Resources, resource requirements, limits requests. Requests that describes the minimum amount of compute resources required. What? Why would I do this for storage? If it defaults to limits it explicitly specified otherwise. What? 1 megabyte? Do you really have to do this? Wait, do I really have to do this? This is that's interesting. Requests. Okay. Wait, what is it? So it's resources request storage. Resources request storage. Okay. Wait. Why aren't you giving me? Oh, it's just key value. Requests 1 megabyte. So that's the interesting. Kubernetes persistent volume claim. Shubap bop wow. Mount options, persistent volume claims. Here we go. Okay, so request storage. Resources request storage 8 gigs. Right. Okay, so if I wanted to, then I could say requests storage and then just do the same 10 gigs. Like that's how much. Yeah, okay. Resources model applies to both volumes and claims. Show me the resources oh, you suck. Seriously? If I click on that, I hate it when this happens. Hey, look at this. Oh, never mind. We archived it. Sorry. That should be fine. This should basically say it's going to give it the full size of. It's going to request the minimum of it, which is 10 gigs. What do they do? I'm kind of curious here. Templates, PVC. Request storage size. Okay, so they do request storage size. Persistent size 10. Okay, so it would be 10. Yeah, it'd be both. All right. Let's try this. This should work. Somebody's at the door. Hang on. Wait, what happened? Wait, what? Argument type, unhandled expert discourse. Request is incompatible index signature. What? Requests. Oh, I did it twice. Whoops. I did not realize I did that twice. There we go. Okay, now it'll work, chat. Now it'll work. My dumb self can type properly. There we go. All right, so let's run this. And we've got our volume right here. Our volume. Yeah, here's our volume right here. It just hasn't been claimed yet. It's retained. So that should mean that, let's do this as well. Let's go here, and then let's do SSH. Nope. SSH, not Kubernetes though. We want NFS, right? And let's do this, sudo serve data discourse. No data is there yet. Oh, what happened? Discourse was not successfully created by Kubernetes. It already exists. All right, you know what? Persistent volume. Wait, that's a persistent volume, though, not a PVC. Oh, look at that. Look at that. Yeah, here. Yeah, there. Stupid volume claim. What's your use case for console? It is the back end to my Vault environment. Yeah, it's the back end of my Vault setup. Okay. Will you work this time? I wonder. I do. Yep. I do indeed. You just can't see it right now. You can see console though, yeah. Come on. Run your update, Palumi. There's our volume claim. That one shouldn't be pending for very long though. So why are you pending? Storage class cannot bind a requested volume discourse. Storage class name does not match. Oh, you stupid. All right, hold on. And if discourse. Oh, geez. Okay. I was right on that one. All right. Update. Let's try this again. Now, I wonder if it's going to know to change. Yep, it does. Look at that. All right. So it's going to change and replace the volume claim, which should be good. This should actually let everything go through. Come on. The original. There we go. There's the new one. There we go. Got it. Now it's bound. All right. So now it's creating replacements. So let's go back to our pods discourse. All right. So now, okay, so it's kicking our Postgres and Redis, which is interesting. Those shouldn't change though. Yeah, those should not have changed. So those are just being rebooted, I guess. Yeah, looks like those are just being kicked. Okay. Deleted persistent volume claim. Okay, so let's go to services and then let's go to discourse. There it is. Okay, so this is scaled down right now because oh no, deployment. Oops, sorry, deployment. This is scaled down right now because I was having issues. So let's scale it out to 3 and let's see if this works. So we're going to go back to pods, discourse. There's our new pods. Now we should get read write any this time. We're pending. Not too sure why. Let's go back to PVC really quickly. Read write. Oh, what? Discourse. Oh, wait a minute. PV. Discourse data. Oh, okay. I know what's going on. I need to redeploy the Helm chart. Or I could do this. I could refresh this. I could just refresh. It's going to take a little bit longer. Okay, so I know what's going on. So this is failing because it's got an old spec to it. I updated the spec, but it doesn't seem to be trying to mount that that, or trying to use the same read, write, execute. So we're going to go back to deployment and discourse and scale it back down to 0. So it's not just like having containers crash. While that is happening, let's go here and let's go back to cluster on-prem. And I want to look at discourse one more time. Okay, so read, write many. That's good. Let's go to K9 really quickly. PVC. See, I only see read, write like RWO. That's weird. PV. There it is. Okay, so we do have read, write many. It is there. It's just being retained. It's released at the moment, but it's being... Okay, cool. So the claim should be the same. It's just out of whack right now because the state's out of whack. Okay, cool. Dope. Well, this isn't so bad. Replica count 3. Persistence, existing claim. It's interesting that it didn't like update the services with the existing claim that I gave it. Persistence. Maybe we should just like make sure that it's enabled. Maybe. Yo, what up, Griffing? How's it going, buddy? Shout out to CM Griffing. Been a minute, man. How are you? Here we go. Be sure to check out that wonderful, wonderful soul. How are you doing, sir? What you doing, guys? How you been working? Oh, jeez, I'm so tired. How have you been? What were you working on? All of that good stuff. Welcome, everybody. I am BG. I'm one of the co-hosts of the ALT-F4 stream. We are a variety stream if you don't know much about us. There you go. There's a little bit of a blurb right there. I am currently working on deploying our new community like feature, I guess. I don't know, whatever you want to call it. So Griffing, I feel like you could probably relate to this even quite a bit. I'm realizing more and more with my stream in general, I find myself kind of going all over the place with what I work on. I don't necessarily work on one thing, right? Like I work in DevOps. So my job in DevOps is to be more reactive. Like, okay, we're trying to do something. How do we do it? You know, that's very much my common problem that I have to deal with. And so there's a lot of content that gets created on stream and in these moments where we're like, oh, okay, we could use this or we could do this or whatever. But I don't really have any other way of really documenting it. And so I came up with this idea. Well, it wasn't really an idea, but it was something that I saw and I was like, okay, this could work for us, of having essentially a wiki for our community. And what I'm going to do is, for starters, be writing a lot more documentation. And then at the end of the stream, I'm going to update all of these documents that helped me get through the problems that I work on stream. So for example, this would be a document on how to do discourse distributed deployments, or at least how I got through that problem. And then, you know, it'll be posted on the on the wiki, and then you can access it and even conversate on it. You know, ask questions and you know, have more of like a forum. You know, exactly. Yeah. The problem for me is like I don't really want to have to turn anything into anything. I almost just want to like generate raw content and be like, okay, cool, there you go. I don't know if that's just like laziness or what, but I've noticed that for me, that at least helps me get it out quicker because I take a long time to do things. So yeah, we'll see. Excuse me. But yeah, we'll but that's kind of what I'm working on. So I'm working right now on deploying it. I initially had it deployed earlier, but as you could tell by this wonderful page, it's broken right now. We broke it. And so I'm in the process of fixing it at the moment, and bringing it back online. And I actually documented that whole process as well. It'll have the VODs in there too, so that you can reference the VODs with the text and all that. So should be pretty cool. What's interesting though, chat, is that this persistence volume stuff is not kicking the change here. So I'm wondering, maybe I'm not using the right, like it's not changing, chat, basically. It should be using my volume or my claim, and it's not. Oh, nice. Well, what were you working on, dude? How have you been? How are all of you guys? How is everybody? Service. This is for discourse, right? Yeah. Image discourse. So discourse dot skip install. Okay. Replica count, extra volume, sidecar service, persistence, enabled true, storage class, existing claim. Did I just did I just spell existing claim wrong or something? Enabled true, existing claim, access mode. Oh, let's do this. Access mode. Oops. Read, write, many, right? That's what we want. Read, write, many. Namespace, metadata name. Yeah, everything should be in the same namespace and all accessible. Just working on Mealection more. Mealection. We are getting users into pre-alpha and fixing. Oh, nice. Very cool. Did you see npm PM yet? No, I haven't. What is that? What is that? You're making all these like fun little apps. I love it. Yeah, I have no idea what you're talking about. So, okay. Interesting. Okay, hang on 1 second, chat. I need to check something. Let's go to deployment. Discourse. See discourse. Dang it. There we go. Describe. Mounts. Volumes. Discourse data. Persistent volume claim. Claim name discourse. Read only false. Oh. I think I can show you guys all of this. I don't think there's anything in here too crazy. Now we debug. The secret. Yeah. It's a game in which you try to find words that aren't in. Oh, really? That's cool. That's fun. So look at this. Discourse data type volume claim name discourse read only. That is the claim name, right? PVC. But it's not there. Why is it not there? Persistent volume claim. But where are you, volume claim? Config, transcode, bound. Namespace, labels, app. This is gonna sound stupid, but like, do persistent volume claims and volumes have to have like different names? They don't have to, right? Like, I mean, I guess I could just do dash data, but I shouldn't have to do that. Yeah, I don't think that's the case. Oh, dude, thank you for. I totally did miss it. Holy crap, man. 30 months, Jesus. Dude, thank you for the 30 months resub. That is that is a while, my friend. That is a while. Thank you. Thank you, buddy. It will trigger the deployment to update though, so whatever. Let's see what this does. So our PV should stay, right? Physical volume should stay. It should just be our claim that changes. So let's see here. Anytime, Palumi. Anytime. There we go. All right, so it created its replacement. PVC. There it is. Discourse data. Pending discourse volume. Created replacement. Persistent volume controller. Volume discourse already bound to a different claim. What? All right. I think I'm going to just do something here. Let's do this. Let's make our lives a lot easier. I don't need to worry about any of this stuff. Like, all of this can go away. So let's just do that. Let's just deprovision it all. Okay. There we go. So we're just going to remove the whole in deployment. Yo, thank you for the follow. There we go. We have the backup. We can restore it no matter what, so it's fine. I'd rather just restore it, to be honest with you, at this point. Completing deletion from previous update. Persistent volume claim. Okay, cool. Backup, which was never tested before. Hey, as long as I've got the articles, that's all that really matters. Should be fine. Should be fine. Not worried about it. There we go. Okay. Pods. Discourse. There we go. All of them are gone. Getting rid of the namespace now. Yo, Lithium X, thank you so much for the resub, man. Appreciate you. The 4 months. Okay. Good. Good. All right, so let's do this. I want to rename this back to whatever I had it as before. I don't need this to be like this if we don't want it, or if we don't need it to be. Okay, cool. So read, write, many, NFS, all of that looks good. All of this looks good. Perfect. Okay. So now that that is all gone, let's reprovision it. One of the nice things about being able to use Palumi is it's very easy to do things like this. Discourse. Really automation in general, though, too. Okay. Cool. That is a long kitty. All right. So this is going to redeploy all of Discourse with a persistent volume claim, all that good stuff. Cool. All right. Let's hope this works. I wonder why that startup takes so long. It says that it's reading the Cloudflare index ALT-F4-wiki. But I just don't feel like, it should take that long. I don't know. Maybe that's just me. All right. So there's our namespace. There's our persistent volume marked available. Do we get our claim? PVC. Pending. Hey, there it is. There's our claim, and it's bound. Perfect. Awesome. Okay, cool. So let's go to pods, discourse. Hey, there we go. Our containers are creating. So is our database as well. This looks pretty good. Come on now. Okay. Still no data in there yet, though. Containers are still starting. Running. Okay, cool. Running. Okay, cool. Now we have a read, write, execute volume, right? It's RWX across the board. So if discourse doesn't want to start, I do not know why it would not want to. And these containers are saying that they're still creating. So let's just move down here. Successfully assigned. Oh, never mind. Never mind. Got assigned. It's going. It's going. Just taking a second. By the way, thanks for introducing me to K9s. I just gave devs across our access to Kubernetes cluster, and K9s made my dev product. Oh man, K9s is amazing. I'm glad you like it, live coding. Yeah, I love K9s. I use it constantly. Cloudflare had an accident just recently by redirecting to some scamish website. Not sure what that was. Some sort of DNS poisoning or misconfiguring. Oh, dang. That's crazy. What are we doing here? Successfully assigned. So we've assigned it, but we're still waiting on. Oh, here we go. Oh, connection timed out. Setup for volume, dismount, fail, connection timed out. Really? So we're getting connection timeouts. Okay. Let's do this. For now, we'll just do star. Let's do async as well. Export fs, and then restart. Oh. Service NFS kernel server restart. Status container config error. All right, this is better. Connection timed out. Okay, so that's okay. That's because of. Yeah, let's do this. Let's delete these containers really quickly. And let's create new ones. And let's see if they connect now. Pulling image. Okay. Sometimes it can be a while. Sometimes it can be something else. Like the fact that it was taking so long to create is not normally a good thing. Unless, again, it's like waiting on something crazy. So connection timed out. I'm still getting timeout connections. How are these timing out? Oh, well, no, that's publicly. 5.6. Yeah, no, that should be fine. And if I do dig kubernetes.nfs.alt-f4.domains. Yeah, 5.6. Huh. So, yeah, I understand that you're pulling the image, but you don't need to. So we're getting closer, but now we're not. DNS not resolved within pod. I mean, it's a public domain. You know what? Let's just do this here, just to make it easier. Let's NFS Kubernetes. Yeah, it should be this Kubernetes ALT-F4 domains. I don't think I spelled anything wrong, but let's just use, let's just try and see 192.168 5.6, right? That's what we said it was, because it mounted it, right? Like it was able to mount it. At least I thought it was. Maybe I was wrong. It's always DNS. I mean, more times than not, you're probably right. Yeah, sure. Why not? Yo, Manny, thank you for the follow. Appreciate you. Come on now. You can do it. If the IP address doesn't work, then I'm slightly nervous that what Orca thought earlier of like being able to use a path inside of it is going to work or not. Might not be the case. I might actually have to export the actual what's it called? Am I gonna be able to delete this actually? Oh, there we go. I don't know if this is going to actually terminate though until the services disconnect from it. Oops. Wait, what? Wait, what? Oh, that was weird. Yeah. Okay, so let's do this. Deployment, discourse, scale, 0. There. That'll at least make it so that those can go away. Then the persistent volume claim and everything can be deleted. I think that's because it's in a Helm. Yeah, see, there we go. Persistent volume claim. There's our bound. Okay. Deployment, discourse. Okay, and it did update it, so it's trying to do stuff right now. Discourse, creating container config. Yep. Well, is that just because it doesn't error can successfully volume for mount of container? What? Subpath for volume mount. Oh, it's not able to create the path. Oh. Okay. That's because it's root. Yeah. Okay. So that's because it's no root squash. That might be what needs to be done. Restart. Okay. Running. Yeah, there it is. So you see how they're running now? That is, yep. Yep. It looks like it's working now. Oh, yeah, and it created it in the discourse. That's interesting. So it created a directory called discourse in the discourse path. We're getting an error. Hold on. Oh, you know what? I think I know why we're getting an error. Maybe. No, maybe not. It looks like it. Hold on. Actually, there, yeah. So it looks like we are stream closed for discourse, starting sidekick. Well, what's the error that we're getting? Failed to create subpath. Oh, it's still trying to create the error. Or it's still trying to create. Wait, what? So, I'm kind of confused right now. Where is it having this problem? Let's do this. Let's go to deployments, discourse, set the scale down to 1, pods, discourse, logs, precompiling assets. So it looks like this is working, but maybe the sidekick is failing. Sandbox changed. It will be killed and recreated. Okay. Started sidekick. Yeah, there you go. So the sidekick looks like it's working now. Yeah, sidekick's running. Okay. I mean, yeah, it looks like something's working. I don't really know what that whole sidekick error thing was, but whatever. Precompiling assets. Okay, so yeah, this takes a little bit of time. I remember this taking some time. But, chat, it looks like we might have our service back up. Potentially. Now, I have a admin username and password that I can log in as. Oh, man, I gotta, like, reset up. Oh, well, no, never mind. That's right. We can do the backup. We gotta do the backup. So I guess I'm gonna log into the admin panel, and then let's do discourse restore. Holy crap, is it really hard to do that? Give me 1 second, I'll be right back. I'm wondering if there's a way to restore it via the control panel. I would assume so, right? Like one would imagine. Oh, there we go. 2 out of 2. Okay, so let's go to here. You install discourse, register, which are fine during setup. That's not right. Okay, there we go. Okay, all right. So I do have preset credentials. You guys can't just, like, steal the account. So let's see if I can access it. All right. Bye. Pulumi config get discourse password. I'm like, oh god, please make sure I didn't do that. So log in. Incorrect username or password. Oh, that's because that's not right. Really? Okay, so I think I know what happened. We skipped the install. Okay, so we we got to do it all again. We skipped the install. So because we skipped the install, it didn't do what we needed. All right, so we got to do we got to do it one more time. But that's okay. That's okay. So let's do this. Let's nvim index. Let's just get rid of all of discourse really quickly. And go here. So because we told it to skip the install, it didn't populate the database. So what's interesting is apparently skip install does not do what I thought it did, and it always tries to populate a database anytime it can, which is that's interesting. I clearly did not understand what install meant. Yeah, let's delete this really quickly. What's also interesting is if we look at what it created, right? Yeah, it created a directory inside of the discourse directory, which I know I don't need that, so I'm kind of wondering if maybe I want to restructure that path so it just mounts it to the served data and then does everything in its new discourse directory that it's trying to create. But I also don't know if that's going to be a... I should probably scope them. Yeah, I should probably just scope them. Never mind. I'm just going to keep them scoped. If it's discourse and discourse, it's really not that big of a deal. But it is interesting that it does seem to not really add much. LS public backup uploads, public plugins. Huh. There's definitely some stuff in there too. That's interesting. All right, we're gonna rm-rf this discourse folder. We've deleted everything, and we're gonna redeploy one last time. This time, we'll make sure that skip install is not enabled. Okay. All right. So we're gonna rerun our automation, and we're gonna redeploy everything. I did disable that, right? Yeah. I'm gonna feel really stupid if I didn't. Cluster on-prem, discourse, skip. I did not. There we go. At least I caught it before it tried doing anything. Enabled access mode, rewrite many. I don't think we need this. Right? Data discourse. Yeah, I think having these isolated this way is going to be a good call. Write many, PVC. Okay, cool. All right, there we go. It's all good. It's a little oopsie. All right, there we go. Cool. So let's do this first. Let's go to PV. All right, guys, have fun. 1 second. All right, did our claim? Yep, cool. It happened. Yo, what's up, Philaic Pharaoh? How's it going, dude? So yeah, and what's actually pretty dope is yeah, everything else went on the vSAN except for the discourse data. That's pretty cool. All right, where are we at with this? So let's go to pods, discourse. There we go. Look at that. Our discourse containers are already running. That's how much faster they should run when everything works, right? So remember, we were talking earlier about how sometimes containers might be taking a while to start or something like that. There can be latency, with regards to like connecting containers to volumes and, stuff like that, but it should be pretty quick. Like how you saw it just work with it normally is how it should pretty much always work. What's the difference between PV and PVC again? Okay, so there are tons of abstractions in Kubernetes, right? And the main reason for those abstractions are so that you can define something logically and not really care about like what the underlying components are, right? So for example, a physical volume is just a logical representation of a disk, right? Like an actual disk, right? What that means in Kubernetes land is that this is the like last stop in the storing of data, essentially. This is okay, like we are we are storing the data here, right? But then Kubernetes also says, well, we don't want to have an opinionation about how that is claimed, right? And so the claim is what actually binds the volume to the container, where it says, okay, I see that there's a physical volume that exists. I now want to claim that, and I want to create a claim with that. And that claim will now have ownership over that specific volume. And so again, it's like layers of logical like abstraction of saying like, okay, I want to do this and I achieve this with this type or, whatever. Does that make sense? I don't know. I hope that made sense. All right, so we're starting Sidekick. All right, cool. So look at this. We are pre-compiling assets now. So we should be getting pretty close to having this thing online. ALT-F4.wiki. Nope, not yet. She's getting there. Let's see what's in here. So we got our discourse folder recreated with our public and plugins. I wonder, yeah, this is barely taking any load whatsoever. Look at this chat. It's like nothing. 229 megabytes out of 8 gigabytes of memory. So this is looking a lot better. The Postgres database, and again, what's also cool is that Postgres and Redis are on the vSAN storage. So if you guys are curious about what vSAN is, don't worry. I'm going to be uploading, or I'm going to be posting all of these articles and all of the discussions we've had today on the wiki. It's the reason why I'm getting it up and running. But yeah, basically the vSAN is our native cloud storage that we use for all of our containers and virtual machines and stuff like that. But we couldn't use that for this, unfortunately. So had to use something else. So this has had 0 restarts, which I would assume means that this is still taking time to start up, and these two can't run until the first one starts, basically. Also, I can't watch these logs for much longer because they do show like sensitive information in them. But it needs to finish compiling your assets. I only got the PV part. The PVC I didn't understand, to be honest. It's a claim. Like, think about it like this. Let's see. You have a car, right? But the keys to that car can be universal, right? The claim that you have to that car is you own the keys, right? It's the same thing with Kubernetes. You can't just like take a car. You need to claim that you own that car, you own that volume. And so when you use a persistent volume claim, you say like, okay, I want to claim this amount of data on this persistent volume, and then it gives you the volume through the claim. You can't just take the volume directly. You have to claim it essentially. Exactly. Yeah, exactly. Yeah, so for example, in my case, Otzi, if I wanted to, okay, there we go. Here we go. Green lights. Hold on one second. We're getting metrics. I should be able to refresh. Hey, there we go, chat. It's back online. Look at that. Our discourse is back up. Okay. Let me see if I can log in really quickly here. Give me 1 second. Hey, and I can log in. Awesome. Okay, so now that we've got this back up, let's go here. Let's go admin. Let's go to backups. Backup. Restore is disabled in the site settings. Oh, okay. How do I enable it? Allow restore, which can replace all data. Leave false unless you plan to restore a backup. I do plan to restore a backup, as a matter of fact, there, good sir. I do. So we're going to go to backups. And where is the restore? Oh, do I need to like refresh it? Maybe I need to refresh it. Chat. Upload. Upload a backup to this instance. Okay. Nope, that's not what we're looking for. Home. Downloads. Here we go. That's really weird. Okay, cool. There we go. There's our backup. We got it. No backups available. Awesome. Love it. Maybe I have to refresh. I don't know. There we go. Okay. I was like, I have no idea. All right. So restore. Here we go, chat. The moment of truth. Are you sure you want to restore this backup? As a matter of fact, yes, I am. Give me my website back. Hold on. I just don't know if there's any logs in here that are, you know, undesirably wanted to be shared. No logs yet. Cool. Oh, here we go. Backup failed. Yeah. Admin has started restore, making restore. Okay, here we go. Create a missing function. Okay, hold on. I think I can show this. Shut up, Kung Fu me. Shut up. Don't jinx me, all right? I want it to work. I mean, it's doing something. What exactly that is, I have no idea. But it is doing something. You were logged out. Oh, I was logged out. Hey, we're back. We got it. We're back. This is it. Like, this is... Now, obviously, we lost our theme, which kind of sucks, but we are actually... We Gucci. Yeah, we got most of the stuff. Okay. So what's interesting, though, is I don't have the ability to log in via the GitHubs, which is kind of interesting. Give me 1 second. I can log in, though, via the main account. Hold on. I'm wondering if it just, like, disabled the theme, or I actually have to re-download the theme again. Doing something. It's trying to log me in. Anytime. There we go. Hey, there we go. Okay. Okay, dope. We back. Hey, chat. Look at that. We back. We back. We did it. Hey, we did it. Yeah. Okay, cool. So chat. This is what I've been telling you about this whole time. This is our wiki. This is really what is going to have all of the information, all of these like articles and stuff that I write while we're streaming. All of this stuff is going to go into this wiki. Not only is that going to go into this wiki, but you guys are also going to be able to contribute to this wiki as well. Now, what I need to do is I need to go to the admin section, and then I need to, hold on. I need to check out the user settings because I know at the moment, oh wow, this thing is like super fast now. Holy smokes, having 3 of these things is a game changer, man. This thing is like very fast now. So again, chat, if we try, there's a login via GitHub. Yeah, so if you guys want, you can try that. I just don't know if it's going to let you because it says, oh, wait, that's not it. I'm sorry. ALT-F4 wiki. There you go. Wiki, not email. That doesn't work. The email thing doesn't work. There you go. So first off, let me know if that works for you guys. Now, remember, this is running in my home lab and in the data center in our garage, really, which is all the vSphere and all of that other stuff. We just replicated it, and now it's running with an NFS backend. So yeah, it's, you know, we're doing some pretty cool stuff here on the ALT-F4 stream. So users, min length, max length. Okay, so sign up. This is what I'm looking for. So invite only, must approve users, login required. Invite code, enable local logins, login based on accounts, login via email. Sorry, this actually, okay, so hold on. I'm going to disable the invite only. The invite only has been disabled. Okay, it has been disabled. Now, I have enabled login via, what's it called? So you guys should now be able to log in via GitHub as well. All outgoing email has been globally disabled by an administrator. No email notifications of any sent. Oh, wait, hold on. Why did that happen? Emails sent to true. An email and all outgoing. Try signing up now if you can, guys. Try signing up now. Basic setup. Display local time card, login, invite only. So you shouldn't, all outgoing has been globally disabled. No email notifications. We cannot detect you if your account was created. Please ensure we have cookies connected. Okay, so yeah, your account was created. It was definitely created. Yeah, I see OTC. You're good. If you log in through GitHub, you're good. Let me figure out why email's not being sent out. Allow custom. Work the second time? Okay, cool. I'm wondering if maybe it's just like slowly updating stuff. All right, so chat, as I said, this is our new wiki. If you guys want to sign up and use it, all you have to do is log in using your GitHub. That's it. That's all you got to do. Let me show you around the place. Okay. Welcome. The first thing I want to point off to you guys is that we have a categories page, or a categories like little browsable section here. Now this is something that the moderators, as well as like you guys through like site feedback and stuff, should provide to us and help us grow. Like this is really a massive like effort here for everybody. I put in categories and stuff that I felt like I might use, and ones that like I feel like we might end up using together. The first thing I want to point out is the technical design documents category. We've talked a lot on this stream about making technical documents and how to share them, and you know, again, I show you guys quite often how I do those things. Well, if you guys are curious on how you could write a technical design document, I actually wrote an article for you guys on how to do it. And the reason why I did this is because I also want you guys to contribute your technical design documents to this. So if you look, not only does it say about technical design documents and what exactly happens in this category, and do I show you how you could start writing your own technical documents, I include 2 that I've worked on here. The first one, man, this thing is fast, chat. Like, this thing is way faster. The first one is the hybrid feature environments, which is something that I've worked on with you guys on stream. I took that whole technical document, I broke it down, and I put it in here. Another one as well was the, if we go back to, it's got backlinking, which is awesome. The Pulumi project repositories. So if you guys were asking, if you guys are asking about how I separate my Pulumi projects and how I structure them, well, these are the technical documents that I write on how I do these things, and like how I do naming conventions and what services have what, and even like namespace conventions, all of that's in here. So if you were to ask me, what do you get out of this? You get like my knowledge. That's the first thing you get out of this, is my knowledge and the ability to contribute and conversate on all of this stuff, right? That's the first thing. The second thing is the Twitch stream section. So for anyone who stuck around through this whole 6-hour stream, thank you so much. I did not expect it to go this long. I really didn't. But we are going to be uploading all of our Twitch streams VODs to YouTube. That's something we're going to be doing for you guys, and it's going to be over a completely new YouTube channel. Actually, it's one that I have. I've got a little bit of time to finish, but it's something that we're going to have. We have the ALT-F4 archives is what we're calling it. And this is where you guys will be able to see all of our past VODs. And not only that, but you're going to be able to go into the wiki and get the notes from those streams. So here are today's notes, chat, where I talked about the agenda and the new community project. I talked about the new streaming computer and why we made the decisions that we made. I also created a wireframe in here of our whole new setup that's going to be in this post as well, right? All of this is now accessible to you guys. And on top of that, not only are you going to get this today and the VOD, which will be posted tomorrow. We have to wait 24 hours before we can post any content from Twitch anywhere else. It's a partner thing. But not only will we be doing that, but I'll also be giving you the Discord distributed deployments article, which was another TDD of how I sat down and figured out how to do literally what I showed you guys on stream right now. I need to be able to deploy my application. I need to be able to scale it. How do I do those things? Oh man, I ran into this problem. How do I do that? All of that. So again, my goal here is to make this be a place that you guys can access on your own, be able to, add and contribute to it as you want. Remember, if you have stuff that you want to talk about, go into DevOps and infrastructure, create a topic. Oh, hey, Otzi, anyone else? I forgot. I put another one in here too. You guys remember this one? I told you that once I found a place for a lot of this documentation, I would make sure that it was available. And so that's what I'm doing as well. I'm going back through all of my documents and I'm getting them I'm getting them added to here too. So a while ago, we wrote a really big document on like, what problems do you need to solve to build a home lab? And this is an ongoing document that I've been working on and writing of like what are the problems you need to solve? How do you configure hosts remotely? How do you manage them remotely? How do you manage Kubernetes remotely? How do you configure hypervisors remotely? What hardware are you going to be using? What are your considerations? How do you all of this stuff is going to be in there too. All of this stuff is a part of the wiki. I obviously ask, please be cool. This is our community. And if you do anything rude or anything like that, you're just going to get modded. You're going to get thrown out. And, that's it. That's just it, This is something that we want to build for people to grow, learn with each other. And again, just another place to where I can kind of dump a lot of content and stuff like that for you guys to be able to ingest. I'm going to be posting these on Twitter as well. So as I post new articles and stuff like that and new topics, I'll obviously post them on Twitter so that you guys can see them. and yeah, be a part. So again, if you guys want to check out the wiki, you want to be a part of the wiki, if you guys want to contribute, whether it be articles or even just check out stuff, it is ALT-F4.wiki. Again, that is ALT-F4.wiki. All you have to do is sign up with your GitHub account. And yeah, this will be something we're going to be growing. This is going to be something that will be a part of the stream. It will be grown, and something we promote more and more as we grow as well. So I hope you guys liked it. I'm going to call it. That's really, I think, a perfect time to sum it up for me. Again, there was a lot of information that we talked about today. If you guys want to know any of it, I am going to post it in the Twitch stream section of the wiki. So if you guys want to see any of the notes from today, be sure to check out that part of the wiki, the Twitch streams. I'll be literally making a new topic and posting in all of the notes that I took. All of these notes, as well as I'll be updating tomorrow or whenever I can, the next day, 24 hours basically, with the VOD too. So here, let's do this really quickly, just so you guys have it. Let's do this. Twitch streams, and then why don't we do this? I have an idea. So we'll do this. Oops. Did I do that right? Oh, I did, yeah. Today's agenda. So what did we do? We talked about the new community project. We then deployed the new community project, right? We deployed it. And then after we deployed it, we had problems, right? So project failed to run due to low replica count. To solve it, to solve for this, we created a new TDD called what did we call this TDD? Discord distributed deployments, which can so we'll do that. And actually here, this is awesome. I actually love the fact that I'm just like dumping documentation onto you guys. Let's go here, technical documents, open draft, create a new topic, link to this topic. Oh, can I do that? Okay, that's cool. I didn't know you could do that. I've never keep editing. So, okay. Create a topic, create a new topic, link to this topic. I did that. Whatever. Distributed deployments. We then redeployed our discourse server with the new configuration. Yo, what's up, Miss Murphy? How's it going? Configuration. And then we restored the instance with a backup before we began. Cool. All right. So that was today's agenda, right? And so what I should be able to do is do this. Create topic. Must be, wait, what? Title must be, DevOps. Or here, we'll say this. 2022 released new ALT-F4 wiki. Yay. This could be our own dev too. That's kind of the point, to be honest with you. 50 characters is a weird restriction. I don't disagree. I think it's just the default. I gotta change it. So I'll probably just change it. Okay, cool. So let's create this topic. For now, I'm just gonna create this topic. So that should be in Twitch streams. Wait, where did that go? Oh, there it is. Yep, there it is. So let's do this really quickly. Admin. 15 character. Yeah, let me see if I can change that really quickly now. Give me 1 second. Let me see if I can change that really fast. Posting. Min post length, max post length, topic view, topic title. Here it is right here. 15. So 20, 22, 20, 22. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10. Okay, that's fine. 10 is fine. Okay. So then we'll go back here, refresh this, and then I mean, I actually don't mind it, to be honest with you. It kind of does force you to have like a descriptive title. I think I might keep it for now. Yeah, I think I might actually just keep it for now. Let's put it back to 15. If more people complain about it, I'll reset it. I have no problem changing it. I'm just actually curious on how, because like it's kind of cool. You can kind of see like, oh, what we did. Okay, so there you go, chat. There is our first agenda post. Let's do this as well. Let's go ahead and now that I've got that, let's get the discourse distributed deployments, TDD. So let's get going here and we will say discourse distributed deployments, right? It's not going to be in Twitch streams. This is going to be in technical documents. And then we're going to grab all of this down to here. Welcome. Paste it in. Yeah, no, I know. I'm always interested in like trying out different options, so you're good. What is our problem? Oh, by the way, chat, this is also something that's really nice. I can generate table of contents. All right, create topic. Yeah, I'm actually very pleased with the performance boost we got out of this. So now what I can do is there you go, chat. There's the distributed deployments one that we just went through. Go back to Twitch streams. Go here, and then say related article or related topics, and then just do that, right? Distributed deployments, and then we can call this. Actually, we don't even need to do that. We can just do this. Do. Oh, wait, what? There we go. All right, so we got that one in there, which is awesome. We have one more piece of information that I need to make sure to give to you guys, which is in these notes, I didn't include our new streaming computer. Thank you. But I need to update this some more before I really kind of go any further. So maybe I add this to this for right now, and then I'll like break it out into something else later. Yeah, maybe that's what I'll do. So I'll just add it to this for now so that you guys have it and you can see it.
Are you ready?
Who's gaming? Probably a Tota behind me. Oh, do you have your... Are you sending out right now? Yeah, I didn't realize that. Okay. Yeah, I know you can. That's fun.
Knew that they cannot
no, I didn't.
Society. Reflecting on themselves.
Can you just disable your line out? That wasn't what I meant. Did you just pull it? You know how loud that is? Sorry, guys. If that was loud, I apologize. Technical changes are always fun. All right, chat. There you go. There we go. So we now have got a few new posts for you guys. So the first article That's new. It was as loud as the music. I believe it. There's our first one, which is the agenda for today. We then also created a TDD as well. That was new right there for our distributed deployments. I would say today has been a pretty productive day. And now I can just like delete these files if I want to, and we're good to go. All right, so chat, thank you guys again so much. I really appreciate it. I'm gonna go ahead and call it here. Remember, we're trying to do a lot of new stuff here. If you don't know, there's a few things I want to show you. First and foremost, we have a new YouTube video, chat. We have a new YouTube video. That is right. We partnered with the wonderful people at Microsoft Azure, and they finally, thankfully, are putting out the whole series every 2 weeks. Every Tuesday for the next 2 months. My bad. No. So for the next 2 months, they are going to be posting the series that we did with them on migrating to the cloud. So if you guys are curious on that, this is the first part of the series, part 1, starting from scratch with Azure, that we did with them. If you guys are curious on that, be sure to check out that as well. We're going to be having those released, like I said, every Tuesday for the next 2 months. On top of that, we have our new ALT-F4 Wiki. Again, this is our new knowledge base / community wiki where you guys are welcome to be a part of the conversation, share your own knowledge, get advice, ask for feedback, all that good stuff. We'll be moderating this directly. We'll be adding more categories. Again, there's a site feedback section in here. If you guys want to give actual feedback that's helpful, please do. It'll definitely help us manage this more. And then what else? Oh yeah, our social media. So on top of that, we do have a wonderful community in our Discord. If you're ever wanting to hang out and be more like one-on-one conversations and stuff, you're welcome to be a part of that. And check out our wonderful community. We also post stuff on our social medias. So every time we go live or just other random stuff on the internet or, anything I'm interested in or ranting or raving about, you can always check out the social media and all that good stuff. Too. So yeah, we're doing a lot, chat. We're doing a lot. We're trying to give you guys a lot, and simultaneously, kind of bring in the new year, really strong. So thank you for being here. Again, be sure to check out the YouTube as well. I'm going to have another YouTube video that I'll be posting alongside of the Azure content here very soon too. So yeah, lots of stuff, lots of DevOps stuff, for your eye holes. Thank you guys again. I really appreciate it. Again, be sure to check out the ALT-F4 Wiki, contribute to it. It would be awesome if you did. And let's go find somebody to raid. So let's see here. Oh, let's go raid Anthony. Perfect. Let's go raid Anthony. Yeah, let's go raid Anthony. Cool. All right, guys, we're gonna go raid Anthony. Tell him I said hello. I'll tell him as well, but you say hello. Enjoy the rest of your evening, guys. Thank you so much for being here. I really appreciate it. Like I said, we're gonna be back to a little bit more of our normal schedule now. So I will be back Wednesday. I'll be streaming Wednesday, as well as Friday this week, and in total we'll be streaming Thursday. We might have some impromptu streams throughout the week, testing out things. Like I said, we've got a whole new setup here. Thank the Lord it didn't crash. Knock on wood. Thank the Lord it didn't crash. So hopefully the new rebuild, which you guys can check out why we did the rebuild in the wiki and all that stuff as well. Okay, bye. Love you guys. Enjoy the raid. Say hi to Anthony. See you guys. Bye.